Right, hi everyone. I hope everyone's back from their break and ready to learn all about Git. So can I just get everybody to, I'll just clear the statuses. Can I just get everybody to put a green tick if they've managed to download the materials and got a GitHub account? So if you haven't, could you maybe post in the chat to say what problems you've been having, or if it's taking a while to download, that kind of thing? Right, sure. So yeah, so the people who still haven't put a tick by as their status in the participants list, are you running into problems, or have you just sort of not clicked tick yet? So I'm gonna be doing this a lot, kind of getting people to report their status by ticking once they've caught up, because otherwise with Git it can be a bit easy to get to ahead of people, and then it can just be hard to make sure we're not leaving people behind. Okay, well, it looks like that's all we're going to get. It does make my life a lot easier if you do tick when you're ready. So I'll just get on it though. So what is version control? I don't know if any of you have any experience with version control, but basically version control is a tool for tracking the changes you make to files. You can track any type of file, but text files work best because with a text file, you can do smart differencing. You can see, okay, well, I've added a line here, I removed a line there, I changed the wording on this particular line, and that allows us to sort of intelligently merge multiple sets of changes together, or to tell, like, produce a clear record of how that file has changed over time that we can display to people. And this is obviously super useful for code because you will be writing code that will evolve over time, and we kind of want to be able to see how that's changing. So why do we use it? Well, one of the reasons is it's a more efficient backup. Imagine if you wanted to keep a backup copy of of your code every single time you make a change. You could end up with, thousands upon thousands of different files, the classic final revision 2, final revision 6, etc. thing, as shown in the Image and PhD comics here. Whereas with version control, you can just say this directory is under version control, and there is just this one file which is my code, and the version control will handle all of the previous versions. They're just sort of hidden away from you, and they're also only stored by differences from the files. So in that case, you don't have to worry about, if that file is 5 megabytes, you're storing thousands of copies of a 5 megabyte file. You're just storing the slight changes that have been made. And reproducibility is a big reason as well, because basically you can look at the version of code from any previous point in time. So you can say, well, when I produced my paper, it was on this particular day. And so I can see, actually, on that day, I was using this version of the code, which means if there are bugs, if there are things that you want to check out, you can always just go back and check. It's like the methods section of your paper, for example. You have got like, you record the methods that you used in that particular paper. You don't constantly keep rewriting the methods sections of your old papers just because you improve your methods. So you have that sense of reproducibility. Another big reason to use it is teamwork, because if you're tracking the changes that individual people are making to files and multiple people are editing files, you can kind of merge together the multiple changes people are making more easily. It's not like, you send a Word document to 2 different people, they each edit it to add lines, and then they send them back to you, and it's like, oh no, now I've got to actually see which bits have been added and merge them together myself. With version control, we can do this automatically. So yeah, version control tracks changes sequentially. So it records individual changes that you've made to files, what's been added, what's been changed, and you can have different versions of a file. You can say, well, here's my base file. What happens if I edit it in this way? Or if I edit it in that way? You can kind of branch off different versions of the same file, which can be useful if you want to try different things without having to keep lots and lots of different copies. Because if your software project involves, say, a dozen files, and you want to try something out that will involve changing a dozen of those files in one way, and then try changing a dozen of them in the other way, it can kind of get messy. But with version control, we've got kind of a neat system for tracking these slight different changes. And also you can merge things together. So if you say, well, I want to make this set of changes and I want to make this set of changes, but actually both of them turned out to be good, so I want to have both of them, version control can merge those things together. So we are going to be teaching Git and GitHub. So there are a bunch of different alternatives and a bunch of different tools for version control. Basically, we're just going to teach Git because it is the most popular one in academia, largely thanks to things like GitHub and GitLab. There is basically, everybody has their own copy of a repository of version control files, and you can kind of synchronize them together through a central site, GitHub. Your university may have a Git lab, but GitHub is kind of the one that's available to everyone. If you sign up for an academic GitHub account, you can have unlimited private repositories. That's the thing that's worth noting. And so we're going to be teaching you Git on the command line because it is a command line tool. There are a bunch of graphical interfaces for Git that have been developed, like SourceTree, Git Kraken, and Git Desktop. You might end up being more comfortable using these. Some of them provide really nice visualizations for how the history of your changes to a file flows between these different branches and different versions. But they are all just front ends for this command line version that we're going to be using. And so we're going to teach you that. It's also pretty important to teach you the command line version, because if you ever end up using things like HPC resources or clusters, you won't be able to use the nice GUIs and you're going to kind of be a bit stuck. So it's easier if we teach you what Git actually does, and then you can either use it from the command line or use graphical tools to call those things, because that way you know what's going on underneath the hood. So the first thing we are going to do is we are going to set up Git. So the problem we have is, despite putting up those prerequisites for you lot, I did not actually clone them myself. So I'm going to do Git Clone. What Git Clone does is it downloads.
We can't see your terminal.
You can't see. Aha, that's a good point. I will just switch. I was running this yesterday on Microsoft Teams, and the sharing system is very slightly different. Okay, so switching to the terminal. So I'm just going to do Git Clone, and that basically has taken a copy of a repository from online to my local machine. You already have done that, but yeah. So now what we are going to do is we are going to configure Git for us to use it. So basically, because it tracks changes to files, you kind of want to associate those changes with a person and have some contact details of that person. And so what we're going to do is I'm just going to press Ctrl-L to clear my screen. I'm going to do git config -- global user.name Sam Mangum. You will, of course, have your own name, and git config global user.email mangum@gmail.com. So this basically is so that when you're making changes in Git, those can be associated with a particular person, which is kind of helpful for if you're looking through the history of changes people have made to a code, knowing who was responsible for which particular changes. So you can ask them why they did that. What was the reason behind that? And we're also going to change the text editor that Git uses. We're going to do git config -- global core.editor nano -w. So you shouldn't have to use a text editor. We're going to teach you ways to do this without it. But in the event that you forget and you accidentally get put into a text editor, this makes sure it's nano and not Vim or Emacs or something equally unpleasant.
So that's really quickly, Sam. That username, is this supposed to match? Because you asked us to log in or register at GitHub, and is that supposed to be the same as what we have there as our username, or is this just free text?
No, so name is just free text for your sort of human readable name. It's the email that matters. The email should be the same.
Okay.
Well, I don't think it actually has to be technically. But yeah, and we are now going to do git config -- list. And so what this does is it shows us the configuration settings that we've got set up for Git. So in this case, you can see I'm using a particular editor. I've got my name and I've got my email. So I'm just going to clear the status markers, and can everybody just do a green tick once they've got git config giving them that output? And again, just post in the chat if you run into any problems. Okay, so the people who haven't managed to get it doing this, what sort of problems are you having?
I got a list of things. Can I send you that?
Yeah, sure. Just post it in the chat.
Sure.
Okay, yeah. So basically, that looks like your Git has come preset with a bunch of settings, which is possibly the case if you're using like Git Desktop or that kind of thing on Windows. So there's a bunch of
I'm on Mac.
Oh, you're on Mac. Okay, well, you've probably got some kind of I don't know if the way you install it is probably just preset a bunch of settings. So those are going to be fine. So there's all sorts of like little tweaks you can do for the performance of Git that they shouldn't actually matter for what we're doing today.
So I have a question. I have another project there. So for that reason, it is showing like that, or it's just.
So if you already had Git installed, presumably whichever way you installed it already set those configuration settings. So those should be the global configuration settings, which will affect every repository that you have. If you go into a repository, you can also set the configuration settings specifically for that one. But again, this shouldn't make any difference. So as long as you've got your user name and your email and your editor set, then everything should be fine. Okay, so we have set up then the repo, well, set up Git rather. So now we're going to move on to how to create a repository. So a repository is a name for the directories that we use to track stuff that's under version control. And since we've already got the files, what we are going to do is go into the demonstration repository with cd swc git novice. So I typed swc git and then tab to autocomplete to fill the rest of it in. And within that, there is a code directory which contains the example code. So we're going to do cd swc git novice /code. And if we do ls, you can see that there is a climate analysis.py file and a temp conversion.py file. So yeah, these are just some example Python files. The actual content doesn't really matter. They won't run, but they just exist as demonstration things. So this directory is not, so this is already part of a different Git repository, but what we're going to do is we're going to say we want to track the changes in this directory specifically. So what we're going to do is git init to initialize a repository. So we've got initialized empty Git repository in home, smangam, git novice, code.git. So if we do ls, you can't actually see this .git directory that it says it's made. But if you do ls.a to show everything, then yeah, you can see the .git directory. So the .git directory is where Git stores all of the revision information, basically, all of the detail on how your files are changing. So if you delete that directory, you stop tracking the versions of files in this directory. So just just leave it be. And now we have our repository set up. And so if we do git status, you will see some information. So we're on branch master, no commits yet, with untracked files. And so untracked files means this is a directory where we will be tracking files, but there aren't any files that we're actually tracking yet. So again, if people can just do yes if they've managed to get to this point. Okay, so let's move on then. So next, we are going to show you how to actually start tracking changes to files. So we do that with Git Add. So Git, being helpful, has told us what it is that we need to do to start tracking files, Git Add File. So we can do Git Add climate analysis.py. So I'm just going to type CLI, hit tab, and temp conversion.py. TMP, hit tab, and then I do git status, and you can see there are changes to be committed, but there are no commits yet. So a commit is basically a specific, like a timestamp on a version of files. So what we're saying here is we have no like recorded version that we want to be able to go back to later yet, but we have files that we do want to record. So we're going to do that with git commit -m for the message. So now we type the message that we want to associate with this commit. So this should be kind of short but descriptive. So for example, started repo or added files is kind of unhelpful because that doesn't let people look back on what you've done and understand why you made changes when. So what we're going to do is initial commit of climate analysis code, and then hit enter. And so now we have a commit. So we've created a record of two files, climateanalysis.py and tempconversion.py. If we do git status, yep, so we can see on branch master, nothing to commit. So what that says is the current version of the files in this directory is basically the same as the last record of, you know, this is a recorded commit of the version of files in this repository at this time. So that's good. So what we're going to do now is git log. So what git log does is it tells you what commits have been made to this repository, what sort of changes have been recorded. So in this case, we've just got one change, which is the initial commit, but it tells you the date it was made, the person who made it, and the email address of that person. There's some extra information as well. So there's an ID for the commit, and there's information on the branch it's part of, and we'll get to branches later, probably tomorrow. So yeah, we're now tracking these files. But now let's actually make some changes to them. So what we are going to do is nano climate analysis.py. So we're just going to use nano to edit one of these files. Okay, so here's the Python file. We're going to add a documentation string at the top of the file that just says climate analysis tools. And then to save and quit, we're going to do Control X and then Y to save the buffer, and then enter to write a file. And now if we do Git status, we can see one file has been modified. And helpfully, Git is telling us what we need to do about this file. Either we can use Git Add to say, okay, no, we do want these changes actually, or we can use Git Restore to say, actually just roll it back to the last version of the file. But we are going to do Git Diff, because Git knows the file's been modified. And so if we do Git Diff, it will tell us how the file has been modified. So you can see there's a bunch of information here, but it's saying there's two versions of files, version A, which is the old one, version B, which is the new one. And it's telling you which lines of the file have been changed. So it provides you with a little bit of context, like the lines that are nearby, and the line with a plus next to it is the line that has been added. It's also highlighted in green on my terminal. Unfortunately, not all terminals will do the fancy highlighting, but it's done that for me. And yeah, and it has information on the indexes of the commits, which is a thing that we'll cover a bit later. So yeah, we can see we've changed this file, and this is how we've changed it.
I have a problem.
Pardon?
I have a problem when I open the climate analysis in Nano. So after changing it, I have to press Control C to cancel and Y for saving it.
Okay, did you not? Because so Nano should have, if you look in the bottom left corner, there should be a thing that tells you how to exit it, and it should be Control X.
And after Control X, I have to, for years, I press Y.
Yep.
Then it's at the bottom, it says file name to write climateanalysis.py.
And then if you hit enter, that should then save to that file name.
Okay, okay. Thank you.
That's right. So just clear that out. And so yeah, we now have a change made to the file, and we are going to make a new commit to the repository. So we're going to commit this change we've made to this file with git commit -m, and we're going to add a message, which is add docstring. So we've added a docstring to the climateanalysis.py file. And that didn't work. And the reason why is because we didn't do git add first. So Git will only track changes to files. It'll only track the changes that you specifically said you want changed, you want tracked rather. So the way we do this is we do git add, like it suggests, climateanalysis.py, and then we do git commit -m add docstring. And it says, so one file has been changed, and there's been one insertion. So one line has been inserted into the file. So that's good. So can everybody just hit yes once they have managed to get this far and they've made those changes and made that second commit? Okay, and the people who haven't managed to hit yes, so are you running into any problems? Okay, so you'd like us to slow down a bit, the pace of advice. Okay, that's right then. I will we've got a bunch of extra time, so I'll just try to be a little bit slower. So still a couple of people who haven't ticked. Are you still working on it, or do you need any help? Oh, that's very unhelpful. Okay, well, we've got 9 people on my end, so that's probably everyone. So if you genuinely aren't ready and you have a problem, can you hit no or post in the chat? If not, I will just move on. Okay, that's good then. So I will try and be a little bit slower. So we're now going to make another change to the file. So we're going to do this with nano again. So nano cl and then tab to autocomplete. So we're going to use nano to edit the file climateanalysis.py. And we're going to scroll all the way down to the bottom, down arrow, and we're going to add a comment. So this is going to be to do. So I'm going to add a to-do note, which is saying to me, I need to add a call to process rainfall in here. Because the climate analysis code doesn't involve rainfall yet, which is obviously not good. So, but again, you don't worry too much about getting the exact text of this right, as long as you know what you wrote. Just having. The important thing is we need a line at the end of the file. And I'm going to do Control X to exit. It's going to ask me if I want to save the file. So I'm going to press yes to save the file. And then it says file name to write. And so if I do enter, then it will write out to that file, climateanalysis.py. Okay. And now if I do Git Diff, it says, yeah, there's been a line added to the end of that file. And again, we can see which particular line. So it's telling us line 26 has been added. And also you can see there's 2 entries there. There's the 2 green pluses at the start of those lines because we've added a blank line of text. We added like a new line and then a line of text. Okay, so we're going to do what we did before then, and we're going to do git add to add this file to the Git repository to say, okay, we want to track this update. So remember this new version of the file and climateanalysis.py, and then hit enter. Great. And now we're going to see what differences there are. We're going to do git diff. And now we don't get any output. So what Git Diff does is it tells you what's the difference between your current directory and the set of changes that you've told Git you want to commit to the repository. So it's just, so the set of changes are sort of sent to what they call the staging area. And from the staging area, then when you do Git commit, they all go. So not all version control systems have this staging area. A lot of them just say, whenever you do a commit, you commit all the files in the directory at once. Git lets you pick and choose because there's some contexts where you might not want to, you might be like, well, I haven't quite finished editing this file, so I'll just commit the changes I've made to all the other ones. That's not great practice, but Git will let you do it. If you want to see what the changes actually are, what information you've got in the staging area that you're going to add once you make a commit, you do that with git diff -- staged. And so here we can see this is the set of changes that we've made and we've said we want to store, but we haven't yet stored with Git Commit. So what we're going to do now is Git Commit -m to add this version of the file to the repository, and we're going to say add rainfall processing placeholder. So again, it's short, but it's descriptive. That's what it needs to be. Gonna hit enter. And it says 1 file change, 2 insertions. So again, it's telling us master and then an ID. These are things we're going to get onto later. And then the commit message and the changes that have been made as a result of this commit. And now if we do Git status, we can see master branch and everything is clean, everything is up to date. But now if we do, yes, there is a shortcut. I don't think we actually include that in materials. If you do git commit -am, you will commit all of the current version of all the files you're tracking. So git commit -am is like, okay, all the files that I've said I'm tracking, I want you to store all the updates. Realistically, that's probably how you will use Git. But we teach you the full process that's going on just so that you know, because you can end up with kind of things being a bit confusing if you don't know that you can choose to commit some files and not others.
So, and I just ask a quick question, please.
Okay.
Does git commit then relates back to the previous git add call? So the git add defines which file you want to later add, because you don't specify the file in the git commit line. Is it because you've already specified it in the git add? That's sort of what I'm asking.
Yes. So just let me switch to the slides. So what git add does is it moves the current, well, it adds the current version of your file from the workspace, so from your directory, to the staging area. And the staging area is this kind of the list of files that you will then want to commit. And Git commit moves things from the staging area to the repository. So once you put a file in the staging area, you can also remove it from the staging area. You can make more changes and commit the file to the staging area again. But you just have this two-step process where you add and you commit. And if you want to combine the two together, you can just do git commit -a, because that's just add and commit everything that we're tracking. So we've done history. So we are now going to, if I go back to terminal, git log. So now we've got multiple commits in our directory. And so if I do git log, you can see, ta-da, there's our first commit at the bottom, which is initial commit of climate analysis code with the date and the author and the commit ID. And then you have the second one, add docstring, and the third one added a rainfall processing placeholder. So we're just gonna move on to using these sort of IDs in a little bit. But what this is it's a hash of the commit, which is just like basically a unique value related to the changes that you've made. And we can use this to identify a particular version of the code. So if you wanted to, refer people to a version of the code that you used in a particular paper, you can be like, oh, we used this commit ID. So that's kind of useful. You can always just roll backwards and forwards through your code to get back to the correct version of it. So if everybody can just do a yes if they're up to speed, if they've done git log and they've gotten this result out of it.
Can I ask a question, please? At this stage, we're just working locally, right? We haven't, nothing's in GitHub or anything like that.
Nothing's on GitHub.
Okay.
So we are going to so given there's only another half hour, I think we're just going to do local Git today. And then tomorrow we're going to move on to GitHub and branches and conflicts.
But say you didn't want to like share this code yet, and you're just testing out Git. No one can see this except you on your machine.
No one can see this. So yeah. So Git is so there are some version control systems where basically you connect to a server and any changes you make to the file are immediately shot up to the server. With Git, it's distributed, so everybody has their own copy of the repository, and there are tools to synchronize those copies with remote ones. But we don't have any remote repositories at the moment. This is all just local. And when you start syncing your local repository up with a remote one, you don't have to sync the whole thing at once. You can pick and choose bits. So this is what branches do, and we'll get onto them later. But if you've got, a few little changes you don't want to share yet, you can keep those local and you can push the changes that you do want to make to this remote repository. But yeah, that is probably going to come in tomorrow. So yeah, so again, I'm going to assume that the couple of people who haven't checked yes are just their version of Zoom is not letting them do it. But please do say if you do have any problems. So we are now going to move on to exploring the history of your repository. So we showed Git Diff earlier and how you can use that to tell the difference between the files in your current directory and the files that were in like the staging area or in the last commit. But what if we want to tell the difference between like different previous commits? If you want to go back in history. So you've seen the word head in the terminal, right? So head basically is the last commit in this repository. So at the moment, head is the version of the repository where we committed the version of the file that has that extra line at the start and the extra line at the bottom. So you can do differences to things relative to that. So what we're going to do is git diff head, and if you want to go back and say, what was it like one commit before the current commit, you use ~1 because you can't use -1. So what we're saying here is we want to compare the current state against the state one commit before the last one. And we're going to specify climateanalysis.py. So what did climateanalysis.py, what was added to that in the last commit? Sorry, did somebody speak? That's right then. So yeah, and we can see between the last commit and the one before it, there was one line added, which was add call to process rainfall. And I'm just going to press up to get to the last line I typed and change that to head ~2 to go 2 commits back. So remember now that the 2 commits back should be the first commit to the repository where we just had the base version of the file. And so in that case, between now and then, we've added the climate analysis tools line and the to-do line at the end of the file. So yeah, that's helpful. If you want to know, if your code suddenly stops working one day and you want to kind of know why that's happened, what changes have been made over the last, couple of commits, you can just do git diff head ~2, head ~4, what have you. Just get an idea of what changes have been made recently. And then you can start seeing, oh, okay, actually, there was a typo in this one particular entry for this one particular file. That's why it's broke. And also, because people put their primary repos. Because people put their names and emails associated with any commit, you can use that information to figure out who is responsible for breaking the code, which is, well, might not be good for them, but it's good for you. There is a command called git blame that you can use for this, but we're not going to teach that today. So What we are going to do though is we're going to start using those IDs that we showed earlier from git log. So let's just do git log again. So we've got these commit IDs. So what if we wanted to check out, to see the difference between our code and a particular commit, one from, you know, a specific date? We can use these commit IDs because we don't want to say like head -30 or head -400 or what have you. That's just inconvenient. So I'm going to copy this commit ID with right click copy. Your terminal might not support that. You might have to do Control-C or Control-Shift-C. And I'm going to do Git Diff, and then I'm going to paste that ID and say climateanalysis.py. So what I'm saying is, instead of the commit that's one behind the head, I'm saying I want to find the difference between the current version of the files and the version at this specific commit using this specific ID. And you can see we get the same output as if we'd just done git head -1, because it's a different way of referring to the same commit, but this one will always be the same. So you can always refer to this particular state of the repository using this particular ID. And that's a really helpful thing, because if you want to tell people which version of the code you used when you wrote a paper, for example, you can say, well, actually, it was this specific commit that we used to generate these specific results. Because otherwise, if they just check out the latest version of your code, it's quite likely that, I mean, you'll have been making changes, you'll be improving it. The results are not going to be the same. And that's a problem. Your research has to be reproducible. And in order for that to be the case, you need to be able to tell people exactly what code you ran. So this is kind of one of the things that IDs are really useful for. But having an ID that is that long is incredibly inconvenient. You don't want to have to work with that. So what Git will allow you to do is use a shorter version of an ID. So you can type the first however many characters are required to have a unique identifier. So traditionally, we use 7 characters because that's almost always enough to be unique for everything. So git diff 00b 72cd 3. So you're going to have your own commit ID. So just type the first 7 characters of whatever your commit ID was. I have typed 8 characters because I can't count. And I'm going to do climateanalysis.py and hit enter. And you can see we get exactly the same output. So we've got a nice sort of shorthand for referring to that commit in a way that isn't like wildly unreasonable. So that is helpful. So can everybody hit yes once they've got up to speed there and they've managed to successfully do a diff against a short commit ID?
Could I ask, so when you're logging the commit IDs to be like this one reproduce this paper, I can imagine that being a bit cumbersome because it's such a long ID, so you might lose it somewhere if you've got it written in a notepad. What's the best way of going about that you've heard for doing that then?
So the best way of going about this is going to be using GitHub. So GitHub has a feature that's called releases, where you can say for a particular commit, this is a release, and give it a name and a description. So when you've finished, when you've got your code up on GitHub or GitLab, they both support these features. You can create a release and say, so this is, you know, the release associated with this particular paper. And one of the things that GitHub can do, which is super handy, is it has an integration with Zenodo, the site for generating DOIs. And so you can have Zenodo automatically generate a DOI for every time you create a release of your code. And that release will link to a specific commit, and Zenodo will automatically have a copy of your code there. And then, because your code has a DOI for that particular version, you can cite your code. And anybody else who tries to reproduce your work can cite the specific version of the code used to create those results. So that's a really powerful, really flexible thing. And I would definitely encourage people to cite their code, because code is science, right? You spend a lot of time writing your code. And if people get more into the habit of citing specific versions of their code, it makes it really easy to make things reproducible, which is like, if your paper isn't reproducible because the version of the code you use is sort of obscure, then you're not doing good science, right? And as well, if you've got software and you're citing it, that just improves your sort of the metrics that it used to evaluate you. And it's kind of important that we pay more attention to the time spent on software and start citing software. Yeah, that's just one of the common hobby horses for research software engineers. So sorry for dumping that. So yeah, and so anybody else run into any problems with getting the diff of a specific version? No, it doesn't look like it. So in that case, let's move on to Git Restore. Well, Git Checkout, sorry. So one of the things I mentioned was that you can use Git as basically a backup system. And you can back up and have records of all the different versions of your files. And that is super useful. So I'll just do Control L to clear my screen, LS to look at the list of files. So we've been making all these changes to climateanalysis.py, but what if we made a mistake and then we deleted it? We're like, whoops, no, I don't care about that. Whatever change I made was garbage. RM, CLI, and then tab to complete climateanalysis.py. So if you remember from the shell lessons, this should remove the file climateanalysis.py. And now if I do ls, you can see the file is gone. But I don't want to delete it. I just want an old version back that's, that doesn't have whatever terrible changes I made. So let's do Git Status. So Git Status tells us that we have deleted a file. We've deleted climateanalysis.py. And conveniently, it tells you the command that you would use to get that back. So you can also use Git Checkout. So Git Checkout is the old command that you used to use, and it still works. We're going to kind of teach you Git Checkout as well as Git Restore, just so that if you go onto a system with an old version of Git, like, for example, HPC cluster or something like that, where they haven't updated the software for months or years because they don't want to break anything. So some of those systems like that won't have access to newer versions of Git. So in those cases, you'll be wanted to be doing Git Checkout climateanalysis.py. So I couldn't do tab to autocomplete the file name there because the file no longer exists. So that wouldn't do anything. So Git Checkout climateanalysis.py. And now if I do ls, you can see climateanalysis.py is back. And if I just do cat to print the contents of climateanalysis.py, you can see it has all the changes up to add call to process rainfall. So one of the things you can also use Git Checkout for is checking out a particular version of a file. So for example, if you made some changes to the file and you realized a few commits later that, oh, actually, the changes I made were a terrible idea, this has broken my code, you can do Git Checkout and then pass it an ID, the same way we used Git Diff and passed it an ID, and say, so actually, I want to get back Git Checkout ID file name. So I want this particular version of this file. And you can easily use that to like compare your current files with your old files, see what changes you made, like revert back to older versions of files that worked better. So it's super helpful. So by just doing git checkout climate analysis.py, that's the same as doing git checkout head climate analysis.py, where head is the last commit. So yeah, we can use any revision identifier if we want, though. So is there a way to get a list of commit versions for a file? Oof, git log climate analysis.py. So git log climate analysis.py has done that. Will git log temp conversion.py do anything? Yes. So if you do git log and then pass it a file name, it will tell you, it will give you a log of the commits that have used that file name. Well, they have modified that file. So yeah, this is the sort of, I didn't know that off the top of my head, because this is the sort of thing that I personally would do on GitHub, where you got a nice graphical interface for it. But everything can be done on the command line. So I think we might call it a day here, because the next bit is a bit more involved and will definitely take more than 20 minutes. So I'll just switch to the slide. So is everybody happy with how to create a repo, how to add files to it, and kind of how to check the different versions of those files and see what changes have been made? If you just hit agree if you are, yes, if you're happy with that.
The only bit I missed, Sam, was where you got the shortened ID.
So the shortened ID. So I won't switch just yet. So you can see in that git log entry, there's the whole massive long ID. So you can use the first, just go for the first 7 characters of that ID is the short version of it. Yeah, it's easiest to just use the first 7 characters. If you want, you can use fewer, but the fewer characters you use, the more likely it is that there's multiple commits with the same first few characters. So basically, just if you use the first 7, you will realistically, you will always have a unique ID. Yeah.
Great, thanks.
So yeah, and the kind of summary of that. So yeah, you can do Git Diff on particular versions of files, restore files to Git Checkout. And so yeah, you can use Git Checkout to check out the versions of a file from a particular commit to the repository, or check out head to get the latest one. And that's basically, that's the basics of using Git for a local repository. Tomorrow we're going to talk about how to sync up Git with a remote repository on GitHub, and as well, everything in that material is kind of the same as GitLab. GitLab and GitHub behave similarly. I don't know if your universities, for example, insist on using GitLab, but yeah, so the stuff we'll be teaching are basically the same for both. And so if everybody is happy with that, then I think we should probably call it a little bit early, and everybody can have an early lunch, and then we can finish this off tomorrow. What is the difference between GitHub and GitLab? Different companies, basically. So they both use Git. So they're both ways of storing Git repositories, but they have little, like, they are like web front ends essentially for managing a Git repository, and for syncing it up with other people. And realistically, almost all the functionality is the same, because it is the functionality that you need for a Git repository. GitHub has, by default, you're only allowed public accounts. If you register as an academic, you can have private repositories. So you can have ones that you only share with a specific subset of people. Lots of universities have their own GitLab instances, which are only accessible to members of their university. And so then you can be like, oh, well, so I'm just going to put my code here, and I don't have to worry about people looking at it on the internet. But I philosophically, I would disagree with making your code private by default, because that's like publishing a paper where the methods section is can't tell you. And also, I don't know how your universities are, but getting people, external collaborators added to a university GitLab can be difficult, depending on how your IT services are. Whereas it's really easy to add new collaborators to GitHub. And also, because it's not linked to a particular university, when you finish your PhD or finish your postdoc and move to a different university, it's still easy to keep having access to your code. And GitHub is also used in industry as well. So that's why we teach GitHub. There's a handful of genuine features that GitHub and GitLab don't share. So things like the Zenodo feature for creating DOIs is on GitHub, but not on GitLab. And there's the other sort of one of the main other differences are things like continuous integration, which is basically, so one of the big advantages of using a remote version control repository is you can set up some like tests, and whenever you make a commit and you send it up to this remote repository, you can run some tests on it to see if it actually passes those tests, to prevent you from accidentally storing broken versions of code in places. GitHub and GitLab approach this continuous integration and automated testing process. They have slightly different systems for it. GitLab makes it a little bit easier to run tests using your local resources. So if, for example, your group has tests that you want to run, but they take about like 20 minutes on a server with 16 cores, GitHub, you will have to pay extra to be able to do those sorts of tests. With GitLab, it's relatively easy to set up a link to like a local server and say, this is the machine that we're running tests on. But it's a swings and roundabouts thing. Unless you need to do that, it doesn't really matter. Right, does anybody else have any questions? Doesn't look like it. Great, so in that case, enjoy your lunch, and I will see you tomorrow at 9 to start talking about how to sync your local repository with a remote repository provider like GitHub.
Could I just remind everyone about feedback in the shared document as well, please?
Oh yeah, of course. Not used to running this one with an Etherpad. Yeah, and the materials we've linked are just, they're going to be there forever. So, well, not forever, long enough.
Thanks.
Right, sure.
Everyone, in the chat you have a link to the Etherpad document. If you can just head over and sign yourself in for day 5, please, below line 37. Let me just give people a couple of more minutes to join. It's Friday, after all.
Plus, we got an hour of Git done yesterday, so hopefully this shouldn't take. Or we might be able to get it done in the first 2 blocks, and then everyone can have an early lunch.
Oh, that's good.
Fingers crossed.
Morning, everyone. So we've got nine learners on the call. Sam, over to you whenever you're ready. If you want to wait a bit.
Yeah, if we just give me another minute or two, because I ran this in between doing the first half of the session, and then now I've just got to get back to where I was the first half of the session. So I'll just be a moment.
Okay, perfect. So that'll give people some more time to join us. And if you have any questions, feel free to ask them now while Sam is setting up about anything you've learned so far, either Git or Python or Shell. Oh, looks like many people are joining now. It's a good call to wait. Morning to everyone who's just joined us. I'm just pasting in the chat the link to the shared Etherpad document. If you can head over and sign in below line 37, that would be great.
So 17 was how many we had yesterday, right?
Let me have a look.
But people still haven't all signed in, so yeah, I'll just wait for a moment.
So we've got, I think, 13 now. On the call. If you've not signed yourself in Etherpad document, please do that now.
Oh, right, number 13 is entering, and then we can kick off, right? So I'll just start sharing my screen for the slides. Great. So yesterday we covered how to set up a Git repo on your local machine to track files in one particular directory and keep a backup of them in like a hidden .git directory within that directory. But as I mentioned at the end of that session, it's not very useful to have a backup in the same place as where you're storing the thing. If your computer breaks, you spill a drink on it, struck by lightning, what have you, you've lost all your backups. So to use Git as a backup and to use it to collaborate with people, we want to be able to work with a remote repository. We want to be able to sync the status of a directory on our machine with a remote machine that can then be synchronized with other people, and we can kind of work together. So we've got the workflow for a local repo. So just a reminder from yesterday, you've got the workspace, which is just the state of your current directory. We can do git add to move a file, well, to put a copy of the file that's in the workspace in the staging area. And then we can do git commit to put all of the stuff we've put in the staging area to just commit that to the repository. And a commit is a record of the current state of all of the files that are being tracked. So for any given commit, because if we remember, commits can have IDs, you can then go back and check out individual files from that commit, or you can look at sort of the difference between one commit and another commit, or one commit and just the current setup of your workspace. So that's what the git add, git commit, and git diff commands do. And there's a couple of extra ones which we've mentioned in this like slide, and there's loads of really good sort of git summaries. What we should probably have one in the material. But yeah, so we've covered how to use Git locally. But now we want to do collaboration. So for example, you've got a repository on your computer, you've got a repository on your friend's computer, or your boss's computer, or have you. You don't have to like them to work with them. And you can sync it with GitHub. So basically, we want to know how to move data from our computer to GitHub. So first things, sign into github.com. Now, you should have created an account on GitHub earlier on in the material. So I'm going to go to github.com and ta-da. So you can see here, this is kind of what GitHub looks like just as a base. So you can see various things various repositories I've been involved in, the list of repositories that I'm sort of a contributor to, notifications, my profile here. And if you want to create a new remote repository on github.com, you can do that by either clicking the down arrow here, clicking the down arrow on the plus and selecting new repository, or if you're on the front page, you can click new, the big green new button. So we are going to click new to create a new repository. And this is like a really nice and straightforward process. So you have a choice of using templates. So you can initialize a repository from a template. We're not going to do that, but if you you have a project that you use as a base and you want to have other projects that are kind of based off of it, then you can do that. That's a more sophisticated feature. You can have owners. So for the moment, we're going to go with the owner that's the default one, just ourselves. But on GitHub, you can also have things owned by teams. And teams are a really useful concept where basically you can create a thing that's not linked to any individual user account, but can have multiple users as part of it, and they can share responsibility for code. And so that's really useful. If you're working on a code for your PhD, for example, it's quite often a good idea to create a new group for that code so that if you leave and the code needs to go on to somebody else, you can just pass over ownership of that group. Lots of multi-person projects work this way, because otherwise you can get problems where, well, I worked on this code, I've quit academia, I'm never coming back, or the person who worked on the previous code has quit and never come back, and you want to make some changes, but you're not an owner, and that kind of runs into problems. So if you've got like a code you expect to be sharing with other people, then creating a group for it is great, or creating a group for your research group. But for the moment, we're going to go with owner of ourselves, which for me is S. Mangum. For you will be whatever user account you use on GitHub. We're going to give it a description. It's optional, but it's always a good idea to write a description just so people know what a repository is. So we're going to say repository
Hi, Sam.
analysis tools.
So this probably isn't important at all, but just wanted to point out there's a very small sort of difference on the version that I'm looking at, and it's on the import repository. So instead of that, yeah, at the top there, I have the import, but I don't have any option for repository template.
Oh,
So
okay. Well, in that case, you probably don't have any repository templates available to you through your.
Okay, so it's just because it's my very first one that there's nothing, there's nothing that I've used before, so there's no template to go with.
I think you have to specifically flag a repository as being a template repository. And so on reflection, I probably shouldn't have mentioned it then, because there is one template repository which is part of an organization that I'm part of that I can use.
Sure. So yeah, that would pop up had I been involved in something that had a template, but probably isn't there if it's your first one.
Yeah. And we're going to name this repository Climate Analysis, because this is going to be hosting our climate analysis repo. So the name of the repository doesn't have to match with the directory that you're tracking. It's often a good idea to, but the important thing is make the repository name clear and descriptive. You're not going to have to type it that many times, so it can be like a moderate length. Don't make it like 60 characters long, a full description of what the code does, but just a couple of words that are clear are better than like ABC5, for example, because it's hard to tell just from looking at your list of owned repositories, what does ABC5 do? So we're going to call this climate analysis. It's a repository of climate analysis tools, and it is going to be public. Anyone on the internet can see this repository. You can choose who can commit. So you have a choice of creating a public or a private repository. So if you've got a free GitHub account, you might not have the option to create a private repository. However, if you're in academia, you can register for a GitHub academic account with a link that's in the materials, and that's fine. You can create an unlimited number of private repositories. You can create groups with private repositories. One of the reasons that your university might have a GitLab instance is because there they can just set up any number of private repositories there just based on you having a university login. But you can get any number of private repositories from just signing up for GitHub Academic. So it's a great idea to do that. And one of the big advantages of using GitHub is it's very easy to invite anybody from any other institution to collaborate with you. All they need is a GitHub account. Whereas with something like GitLab, what they will need is to be added to your university's authentication system, which in our experience has not been as easy as we would like. Your experience may vary. So you can initialize a repository with various things like a README file, a git ignore, or a license. Licensing is quite important. Unfortunately, we're not going to cover it today. But we're importing an existing repository. So we're just going to do create repository. Great. So quick setup if you've done this kind of thing before. So just make sure that you've got HTTPS clicked. It might default to SSH, but please click HTTPS. GitHub is there's a couple of different ways of authenticating when you want to link to your remote repository, and GitHub is trying to move everybody to SSH because it's more secure, but it's harder to work with. And so because this is like a basic introduction, we're going to use HTTPS. And you can see push an existing repository from the command line. So GitHub is giving us all the instructions we need to set this up, but we're just going to copy the first line. So we're going to select existing repository here, copy it, and then, so I am not in my repository right now. So if I do ls, I can see cd swc-git-novice.
Oh, we can't see you.
Some can't see your screen. You're only sharing your browser window.
Sorry, this is the problem with flipping back and forth between teaching on Teams and teaching on Zoom. Okay, thanks for that. So we are back in the shell. So if you haven't already, open up a shell window and go to where you have stored your Software Carpentry Git code yesterday. So that should be, if you just did everything the following the examples, should be in swc-git-novice/code. I've got an old one there because I taught this yesterday as well. Okay, and if I do ls, you can see we're in the file in the directory with climateanalysis.py and tempconversion.py and git status on branch master, nothing to commit, working tree clean. So we are going to do right click paste, or if you can't do that, it might be Control-Shift-V or Control and insert or Shift and insert, or you can type it out yourself, but that increases the odds of you making a typo. And so what we're doing now is we're telling Git to link to add a remote repository, so a new remote repository, and we're going to call it origin, and the URL that's associated with that remote repository is github.com/climateanalysis.git. So just going to hit enter to do that. And I don't get any output there. However, if I do git remote -- verbose, you can see, oh, my text size is probably a bit large. Is the text size for the terminal the right size for everyone? Can you read clearly? Can I afford to drop it a little bit?
It's very clear for me.
Okay, I might just shrink it a little bit because it's making it hard to have everything on one line. Okay, so now we can see that a remote has been added to our repository. So verbose is basically just listing in detail all of the remotes that we have and the URLs associated with them. So you can have different URLs for fetch and push, but the odds of you needing that are very slim. And the point at which you need that, you will know enough Git to be able to read the tutorial yourself. So we're not going to worry about that right now. I don't think I've ever had to implement it myself.
Sam, sorry to interrupt. I got an error message saying remote origin already exists.
Are you sure you're in the code directory?
Yep. If I list, it's got climate analysis and temp conversion.
So if you do git status, what does it say?
Nothing to commit, working tree clean.
Okay, and if you do git remote -- verbose?
Origin, yeah, I mean, it gives the output that's shown a couple of lines up on your terminal. So,
maybe you just ran the command twice, Mike.
Yeah, I was going to say that's what happened to me. I ran it twice and I got that.
If you did git remote add origin and then the URL, maybe twice, yeah.
okay.
That's good then. So that's all fine. Yeah, so you can, the advantage of git remote -- verbose is it tells you the way things are currently set up. So if you run into a problem, you can always see, well, actually, is it pointing at where I want it to be? Oh, okay, yeah, it's just a bit of an issue. So, and we are now going to synchronize our local repository with our remote repository, and we are going to do that by pushing the commits from our local repository to the remote repository with Git Push. And we're going to do origin, because origin is the name of the remote repository we want to push to. And now we give the name of the branch we want to push to. So we're on branch master, as it's just said in Git status. And so we want to push that to the master branch on the remote repository. Git push origin master. So GitHub are trying to get people to move away from the master terminology towards main terminology, but the command line tool Git itself still automatically creates a branch called master. So for the purposes of this tutorial, we're teaching master. If you would prefer to switch the name to main, there are other tutorials to do that. But we're just going to stick with master just because this is what Git does. So Git push origin master. And now you enter your username and you enter your password. So yours should be different from mine, I would hope. And now you can see So we're enumerating objects, counting them, compressing them, and then sending them up. And so we have created a new branch on our remote repository called master. So this little bit here says we've pushed from the local branch master to the remote branch master, and we've made a new branch. Great. So can everybody just tick yes if they have managed to get this far and managed to sync their local repository up with the remote repository? So the people who haven't clicked tick, if you are running into problems, can you post in the chat?
Yeah, Sam, could you just scroll back up your screen a little bit? Because I think I missed a couple of commands.
So
that's great. Thank you.
So I think the highest number of ticks you managed to get up to yesterday was 9, which I assume is the limit based on the number of copies of Zoom that are currently supporting that feature and not bugged. You just get an error. So can you put that error in the chat? So in general, when you're reporting an error, it's best to give the error message because there's any number of things that could go wrong. And so it's kind of helpful for us to know the specifics of what it is that's gone wrong.
Yeah, it just takes a bit of time to type. Hang on. I can't copy and paste it because my terminal, I don't think allows that.
I'm making Mike a co-host as well if Mike wants to share his screen.
Sure thing. Can you see my terminal?
Yeah, so the problem we have here is, as you can see, it's when you look at the output of git remote -- verbose, it's telling you that the origin that it's got there is not the same as the origin that you typed. So the origin it's got there is the Southampton RSG SWC Git novice one.
Yeah.
So what that means is you didn't actually initialize a new repository in the code directory yesterday. You kind of because the material has been downloaded from GitHub as a repository, it already is one. So you have to go into the code directory and git init to create a new repository. So at the moment, that's why it's telling you that the origin is the URL that you downloaded it from originally, not the remote that you added later on.
Okay.
So what you're going to have to do is git init to initialize a repository.
Just that.
Just that.
Okay.
And now if you do now if you add and commit all the files in the repository, it doesn't matter that you won't have the same commit history. We just care about having them in the current status.
Okay.
So do you remember how to add files?
Oh, I've just gone straight to the commit.
Oh yeah,
can I skip the add?
Well, so git commit -a commits all files you have added.
Yeah.
At any point in the past, and you haven't added any of these files, so you're going to have to do git add to add the files.
Okay. Is there a flag to?
You have to provide the file names of the files you want to add.
Oh, right. So they.
This is going to be a good recap for everyone else as well.
Yeah.
What was done yesterday.
Okay, and now you can do Git commit. And then, okay, so now you can enter the message that you want to use for the commit. So if you do Git commit -am, you'll be able to just type the message on the command line.
Right, okay.
Okay, and now just hit enter and then yes. And that should, okay, yeah. So if you do Git commit -am and then include the string, which is the commit message. So open quotes and then describe the thing. Great, there you go. Did you do the Git config steps yesterday to set up your username?
Yeah, I did, yeah.
Okay, that's interesting. Never mind then. So if you just, now you can do the Git remote add origin step again. So if you press the up arrow key, you can scroll through previous things you've done and you'll eventually get back to it. Oh, there you go. And now you can do Git push origin master and we'll be all up to sync.
Yeah, so it's asking me to sign in on a separate window. Cool, thank you.
Great, so did you get Git push origin master to work?
It's just opened a separate window and asking me to sign in on my browser, although I am signed in on the browser, so I'm not sure why.
I think something maybe with the Git config.
Yeah, I think this is one of the fun...
On the command line, didn't...
The problem with most of us not using Windows in our day-to-day lives is there's these things that it likes to do sometimes we're not familiar with. Okay, brilliant. So you are now up to speed.
Cool, thank you.
And so if we just, I'll just share screen again and go over to here. So here you can see if you go back to your page on GitHub and you refresh it, you will see your climate analysis code with the files analysis.py and temp conversion.py. And you can click on them, look at the contents. It's all nicely syntax highlighted. And you can see the history of commits to that file in the same way as if you just done git log, but this is a nicer sort of graphical way of looking at it. This is great. We've got the whole history of the changes made to our repository synchronized to our remote repository. So that is brilliant.
Sorry, Sam, how did you see the history again? I missed it.
If you click on any particular file, so I'm going to click on climateanalysis.py, and then there's a little history button on the right-hand side. So it tells you when the latest commit to this file was. It gives you the ID of the commit, and it gives you a link to history. So I'm going to click history, and you can paste the commit IDs. So this is useful for like if you want to check out a specific version of the file. You can view the entire repository at that point in history. So you can say, oh, actually, you know, 3 weeks ago, my whole repository looked like this as opposed to the way it looks now. And basically GitHub lets you do all of the like the diffing and the history exploration that you can do on the command line, but in a nicer, clearer way. So we're just going to go back here. And you'll notice there is this bit here at the top, which is like the branches. So you can switch between branches. There's only one here now. We are now going to talk about what a branch is, because we've seen them pop up a couple of times so far. But what are they? So branches are basically alternate versions of history. So why is that useful? Why would you want to, like, a branch is a separate copy of a separate version of all of the files in your repository. So if you have this one directory where you have all your files in, you can create a new branch, modify the files, and have a slightly modified version of the files, and then switch back to the original version by switching branch back, back and forth, and look at the different versions. And you can merge changes from one branch into another branch. So this is a really good diagram for kind of thinking about it. The dots on this diagram represent the commits. And so you branch off from one branch and you make commits to that branch, and then you can merge them back in to the original branch. So why would we do this? Well, there's basically one good reason for this, which is if you're developing on GitHub, well, if you're developing on your local Git repository, you want to keep synchronizing your code up to GitHub, right? So it's secure, it's safe as a backup. But also you want to use GitHub to share your code with your collaborators, with people who want to reproduce your papers, that kind of thing. And if you have one branch and you do all of your development on that branch, it's kind of messy, right? You might be committing broken code to that branch, and then people will be like, oh, I want to try out this new repository, and they'll download a copy of it and then it won't work. Or what if you're halfway through adding a new feature? Say there's a whole new category of model you want to add, and that's going to take a while and things are going to be broken until you finished adding it. But then somebody who's trying to reproduce your paper points, maybe they have correctly checked out one particular commit of your repository, but they found a bug in it. And like, oh, in order to, pass review for the paper, we're going to have to get you to fix this little bug and produce the correct plots. But you can't do that because you're midway through working on a feature that will take weeks or months to complete. So you're going to have to finish that feature and then fix the bug. So that's kind of a problem. So we get around this with what's called the feature branch workflow, basically, where you have your main branch that is the version you want other people to use. You have your development branch, which is the version that's kind of the work in progress one that's sort of slowly evolving, and eventually that will become your master version when you use it in a paper. And you have feature branches where off this development branch, you create these little side histories where you can fix a bug without affecting all of the other work you're doing, or you can add a new feature without affecting all of the other work you're doing. So that might seem like a little bit difficult to get your head around when you've not had to deal with this situation yet, but we're just going to kind of give you an example of how this works. So we are going to create branches and check them out using git branch. Let me switch back to the terminal. So I'm going to do Control L to clear my screen just to make it tidier. And so the commands to create a new branch in Git is git branch and then the name of the branch you want to make. So traditionally, you normally have your master branch, which is the version that contains like the stable versions of code you want to share. So, when you use code for a paper, you'll make a commit to the master branch with that version of the code. And the development branch is for just sort of working on. So we're going to create git branch dev. And if we do git branch now, we can see the list of branches. So that's good. We've got dev and we've got master. And the asterisk indicates we're currently on master. So any commits we make now will be committed to the master branch. We want to make changes to dev. So we are going to do git checkout dev and then git branch. And we can see it's told us we've switched to the dev branch and the asterisk shows we're on dev. So my terminal is highlighting things nicely in green to show the branch I'm on. Your terminal might, it might not. So if you've actually made some changes to files and you switch between branches, you can get errors. So always make sure you commit all of your current changes before switching to a branch to make new ones. Otherwise, you might end up accidentally committing to the wrong branch, which is a nuisance. So now we are going to add a new file to our repository, and we're going to call it rainfall conversion because we said in the edit we made that we want to add a call to processing rainfall. So nano rainfall conversion.py. And so this is, again, you don't need to know Python for this, although you already do. So we're just going to type out a small little file for rainfall conversion. So the doc string for it because everything should be documented. And we're going to call this function inches to millimeters. And it takes in inches. We're going to add a doc string for this. It's a bit of a bad doc string because it's not very descriptive, but. And we're going to do the master code. So millimeters equals inches times 25.4 and return millimeters. So what this function will do is take in the rainfall in inches and convert it to the rainfall in millimeters. Nice and straightforward. And we're going to do Control X to exit, Y to save, and then enter to save with that file name. And now if we do Git Status, we can see there is one untracked file and we're on the branch dev now, not the branch master. So make sure that Git Status is telling you that you're on the dev branch. And then we're going to do Git Add rainfall conversion.py. So I did Git Add RAI tab, Git Commit. Oh. Okay, so which code are you talking about? The rainfall conversion.py file? Yeah, okay, so the contents of that one are also in the materials, but I'll just open it up again. So I'll do cat rainfall conversion.py. So cat lists the contents of a file. So there you go. The specific contents of this file aren't really important. It's just sort of an illustrative thing. In fact, if you want, you don't have to use 25.4. You can decide that an inch is however long you would like it to be. Yeah. Okay, so maybe if people can, where's the participants list gone? That's better. So if I just clear all, if people can just do a tick once they have reached this point. Are all synced repos all aware of all branches? And the answer there is no. So you can choose which branches you push to a repository. I think you can set different branches. So you can as well, you can set the default repository for any given branch, which we're going to do later. So if you want, you can have a repository that pushes one branch to one remote repository and another branch to another remote repository. In general, don't do that. Git is a very powerful tool that was designed to help manage development of like Linux with hundreds of developers. So it has all sorts of incredibly powerful features, most of which you will never need, most of which I have never used. Almost everything I do is basically just git add, git commit, switching branches and merging. There's all sorts of fancy things like rebasing and squashing, which mostly exist to make your life harder. I don't know if the other people here will, like assistants and things, will agree with that, but I normally just use the basics of Git because if you try to get complicated.
It is quite advanced, and most of the time you will probably just use maybe the simple workflow where you commit, you do something on your machine, and then you commit those changes back, you sync those changes back to the remote repository. So you might want to work on a branch, and then you want to merge that branch later on with master, as Sam will show you, and then you will back it up on GitHub. So you might find working on your own on repository, in which case you will have a simpler workflow. The moment someone else starts collaborating with you on a repository, things start to get a bit more complicated, but also exciting, because you can work with someone and merge both of your changes into the your project.
Great. So I think everybody is up to speed now. So in that case, so if I just do git status again, you can see
a really quick question. Sorry, I just got LF will be replaced by CRLF.
So this is because you're on Windows.
Okay. So
Git is actually really helpful there, because in Windows and Linux use different line ending characters, line feed versus character return line feed. And what Git does is it automatically converts. If you're working in Windows, all of your utilities will add Windows line endings. But that means that you've run into massive conflicts when you're working with people who work in Linux, where they're using Linux style line endings. And so Git will automatically convert, when you commit a file, all the Windows line endings to Linux line endings if you have a setting set. And that's really good, because if it doesn't do that, and I've seen problems that happen when it doesn't do that, you will commit a file and you'll be like, oh, I've just added one line. And the actual recorded difference for that commit will be you added one line of text and you replaced all of the Linux line endings with Windows line endings. And then the next commit by somebody on Linux is going to be, I added one more line of text and changed all of the line endings back. And so that's absolutely terrible.
I've had a worse problem with that actually once, when I wrote some software before I went to university during a year in industry, and there was a parsing error due to mismatched carriage returns, and someone ended up driving down from Manchester to Oxford with an entire van full of equipment that this computer was controlling, for me to sit in my student house and debug what the problem was. And it was exactly this. So thank you.
That's good then.
Hello, I got this error, thing. I don't know, it's an error or something. It's different.
That's not an error. That's just telling you the current state of your repository. So I did git add to add the file to be tracked. So if you look at what's on my terminal, it says changes to be committed. So these are the files that are in the staging area. So the way we get files into the record of what will be committed, the way we add them to the staging area, is with git add. So Git is telling you, use git add file to add that to the list of what's going to be committed. So this is a really good thing about Git. Whilst it is a complicated and messy tool, normally it tells you exactly what you need to do when you run the commands. And so it's just kind of, there's just a bit of like building up the confidence that, oh no, actually, yeah, that is the correct thing.
I got it.
I have done git add rainfall conversion.py and git status. So yeah, rainfall conversion.py. And now I'm going to do git commit -m add rainfall module. So I'm adding the rainfall. So I'm creating a new commit on the development branch, because git status says on branch dev, that has the message add rainfall module. So you can see there's a slightly different output here to what we've seen before, because it says dev instead of master. So this is saying we've created a new commit on the dev branch. This is the ID, that's the message, and we have created one file by writing 6 lines, or however many lines of text you wrote. So you might have written a slightly shorter function because it's a bit inefficiently written. So that's great. So now if we do git log, we can see, so now we have a new commit in the log with its ID, and you can see head is dev. So it's saying the current state of the repository is the development branch. And you can also see the commit before it says master. So what we can see is this is the last commit in the history that was on the master branch. So we have sort of branched off, from the master branch, and we've created the development branch. So it goes master, now we're in dev. And so now I'm going to do Q to exit git log and ls to look at my current file. So I've got climate analysis, rainfall, and temp conversion. And I'm going to do Git Checkout Master to go back to the master branch. Switch to branch master. And I'm going to do ls to look. And you can see now there is no rainfall conversion.py file. So when we made that file, we committed it to the development branch. We didn't commit it to the master branch. And so now we're back on master, the file has gone. We can't see it. But if we do Git Checkout Dev again, and then ls, the file is back. So it was just safely hidden away in our hidden .git directory, and now it's back. So again, this is handy because you can have multiple versions of the code in the same directory that are really easy to switch between. So if, for example, you want to compare, say you're trying to add a new feature and you run that and you see what the output is, and you want to see, oh, actually, what changes to my simulation have happened as a result of the changes I've made compared to, you know, what it used to be. You can just check out your master branch, run your master branch, get the output, then check out your dev branch, run the dev branch, get the output, and say, oh, okay, well, actually, my dev one has differed in this way. It's sort of better, or it's worse, or it's buggier. So it just makes it nice and easy. So,
Sam, sorry, can I jump in? Mine's showing rainfall conversion py in master, even though I haven't run a commit. I've done since creating the rainfall conversion.py. I've done git add the file and then git status, and it shows that there's a new file.
So when you did git status, what branch did it say you were on?
Dev.
Okay. So did you add and commit the file whilst you were on the dev branch?
I've just done git add rainfall conversion.py. That's it. And then gone status, it says new file. Then git log, it says.
Right. So remember, when you add a file, you're adding it to the list of files that will be committed when you run git commit. So what you need to do is make sure that you're on the dev branch and then do git commit whilst you're on the dev branch. And that will say the creation of this file is something I want to associate with the dev branch. So make sure that you do git checkout dev and then do git commit.
Okay. So sorry, just to recap. So I was on the dev branch, made the file, added it to the staging area. Then I switched back to master using checkout and then ran list, and it was showing up the file.
Yeah. So it's only when you do git commit that you are saying this is the status of the repository associated with this branch at this time. So because you didn't commit the file, commit the change, which is the creation of that file, to the development branch, Git hadn't associated it with that. It's like, okay, well,
right.
You've made it, but so yeah, this is why it's really important to do git commit.
Okay, so I do git commit the file, and then while I'm in the dev branch, and it will go to the dev branch, basically. Is that right?
Mm-hmm.
Okay.
Great. So is everybody up to speed now? Just use a tick if you are. Okay, that's probably enough people. So we talked earlier, so somebody mentioned earlier, are all remote repositories aware of all branches? And the answer is no, not unless you make them aware of it. So we're going to do that now. We are going to go back to our dev branch with git checkout dev. So this bit's quite important. I'm already on dev. You might already be on dev, but it's just really important to make sure that we are on dev. And we are going to do Git push again. So we're pushing the changes from our local branch to the remote repository, which we're going to use origin. And we're going to push it to origin as a new branch with the name of dev. So that's going to match the name of the local branch, which is, it doesn't have to be the same, but it should be, otherwise things get messy. So we're going to do git push origin dev. And username, again, this is a bit I can't help you with because that will be yours. And you can see we have created a new branch there called dev. So is there anybody who has not managed to get git push origin dev working? So the important thing is that when it says new branch here, you can see it's from dev going to dev, dev to dev. Okay, and now we are going to try and pull the changes from the dev branch into our master branch. Because say we've decided that this change is good enough that we're happy to include it in the version of our code that we're going to share with other people, that is going to be part of a paper. We're going to want to move the changes from dev into master, and we are going to do that via a pull request on GitHub. So let's switch screen back to the wonders of GitHub. So climate analysis.py, the climate analysis, so back on our climate analysis repo, and you can see now it says dev had pushes less than a minute ago. So this is helpful. So if I just click on this down arrow here, you can see branches. Oh, I might have to refresh for this to work. So here, this bit here is the branches. So if I click on dev, then I can see I have temp conversion.py here, rainfall conversion.py created 9 minutes ago. And you can see this clock here tells you the number of commits, 4 commits. And if I go back to master, rainfall conversion.py doesn't exist. So we want to put rainfall conversion.py into the master branch, but fortunately GitHub gives us a big compare and pull request button. So master branch is a convention. So GitHub has a default branch, which will usually be the master branch. But Git itself, I don't believe treats any branches differently. It's all just convention, which is why if you want, you can rename master to main because it's just a branch. So we're creating a pull request. So the title of the pull request is add rainfall module. We're going to add a comment here, which is adding a new module to convert rainfall measurements. So the pull request interface has a lot of really useful things that you can do, particularly if you're working as part of a group. So one of the things you can specify is the reviewers. So nobody else is working with me on this repository right now, but if you add collaborators, you can request people to review the code. You can be like, well, I'm not entirely sure. I just want to get somebody else's eyes over this code before I put it into the master branch. So this can be other PhD students, industrial collaborators, your supervisor, if they know how to code, hopefully yours will. So yeah, and they will get a notification saying, hey, could you please review this pull request before it gets merged? It's very common in industry, not so common in academia because you tend to be working on smaller teams. You can assign somebody to work on it. So if you want to set up multiple pull requests, you can kind of assign yourself to one when you start working on it, so people can see who is working on which branch, which pull request. And there are labels. So for example, you can do label bug if this is to fix a bug, or documentation if it's to add documentation. We are going to label this as enhancement because we have added a new feature to the code. So again, you don't have to do this, but this is useful to kind of provide information on what's going on with your code. And there's some other advanced features which are handy, but we're not going to cover today. So now we're going to hit create pull request. And you can see the commits that the pull request wants to add, the label, and you can see it has no conflicts, and we can do this automatically. And if we click on files changed just up here, we can see we've created a new file, rainfallconversion.py, which in the original version doesn't exist. So the version on the left doesn't exist, the version on the right, these are the changes we've made to this file, and the changes are all of the lines. So I'm going to go back to the conversation, and I'm going to click merge pull request. So this is a really nice graphical way of doing this. And I'm going to just leave this as default, although you can provide extra information if you want. Choose which email address to associate. I have too many email addresses, and confirm merge. Pull request successfully merged and closed. We can now delete the branch if we want. Don't, because dev you want to keep working on. You're going to be doing lots of work through dev. In general, it's best not to delete branches just because they don't take up a lot of space. Only once you start getting like dozens and dozens of branches is it worth bothering to delete the old ones. You can delete them on your local repository if you want, but in general, keeping a record of everything is easier just because it means that you can go back and figure out what you did. So I just check what the schedule is. When is the next break lined up? I'm not sure if I should be stopping.
I think it's up to you, Sam, really. So about hour of teaching, and then we try and have some break. So whenever you find a convenient point to stop.
Yeah, I will just finish this bit then. So this is good. So now if you look at GitHub, you can see on the master branch, we've got rainfallconversion.py. So we have successfully merged the changes from our dev branch into our master branch. That's brilliant. But if we do git branch on our, I'll just switch back to the terminal. So yeah, so if I do git branch on the terminal, you can see we're on the dev branch. So now I'm going to do Git Checkout Master and ls to list the files. So whilst the master branch on my remote repository has the rainfallconversion.py file in, the one on my local repository doesn't. So how do we update it? We do that with git pull. So we're going to do git pull. So this is the opposite of git push. We're pulling the changes from the remote repository to our local one. And we're going to do git pull origin because we want to pull from the remote repository we labeled origin. And we're going to pull the branch master from origin. So make sure you're on the local branch master and you are pulling the remote branch master. So we're going to set it up in the next block of work to select the branch by default just to make life easier, because obviously this, if we keep doing it this way, we can make mistakes. But for the moment, git pull origin master. Brilliant. And so it will tell you that it has fetched the update to master branch. It's created a new file. And if we do ls, then we can see everything. Rainfallconversion.py exists. So that's this block of teaching. If we have a 15-minute break, then if I just get the, because I should be trying to follow the actual schedule. Oh, okay, the break is supposed to be at 10:15. So in that case, people have just enough time to do the exercise. So if you go to, I'll just link it in the chat. So these materials, if you go down to the bit at the bottom where it says exercise feature branches, we're going to try adding a new feature. We're going to add some documentation, and we're going to create a new branch that comes off of dev that's called doc, which, in which we're going to add a readme.md file. So every code should have a readme. So we're going to go onto our development branch, create a new branch coming off of that called doc, the same way we branch development off from master. We're going to create a new file on our doc branch. We're going to commit it to that branch, and then we're going to sync that up to our remote repository. We're going to do a pull request on the remote repository to merge, to pull doc into dev, and then we're going to pull dev back down to our local machine. So I will just put the slides for that up. So this is a more complicated thing. So if you run into any problems, do not hesitate to ask. But so yeah, so this is an important workflow to get down, just because it means you can create a new branch to add you can work on multiple different features at once without them affecting each other. You can work on a new feature and fix a bug without having to finish one before you do the other, that kind of thing. So this is the exercise, and if you run into any problems, just don't hesitate to say, and we'll have like 10 minutes to do this, and then we'll go on a break. So once you've done the exercise, can you do a green tick, or if the green tick isn't working, can you just say that you've done it in the main chat?
Hello.
Hello.
Hello. That's a quick question while we're just people are doing that. One thing that I find disorientating is that when you're going through this, some of the notation on GitHub I find a bit confusing. So you upload a new branch and then you're considering merging it, but it kind of keeps using the language pull, which in my head, push and what you were doing in the terminal, push and pull are kind of about pushing the the branch up to the repository, up to the GitHub, or pulling it back again. But then you've kind of got that language to do with merging branches within GitHub as well, in terms of the way the buttons are labeled. I mean, I'm kind of doing it because that's what you told me, but I'd never have guessed because the way it's.
So because GitHub is set up for collaboration essentially, and so pushing and pulling are basically the same thing from two different directions, and a pull request is you requesting that somebody else pull your changes, into their branch.
Right.
So you could push your changes to their branch, but a pull request is saying, here are my changes, please have a look at them. If you agree with them, pull them. And so those can both be types of merge.
That makes more sense. I think it's because I'm thinking about it because I'm talking to myself.
Yeah, so this is kind of the issue, and you don't have to follow the workflow where you push your code to GitHub and then you pull the changes from dev into master, for example. But yeah, but yeah, that's the workflow that you will do if you end up working with anybody else, essentially, because you don't want to make changes to the code without having like a nice clear record of like one of the big advantages of pull request is you have a nice searchable record of this is a new feature that was added to the code by this person on this date. And technically that information is available in commit messages, but if it's a pull request, it's in a nice, easily searchable online format that just makes, like, it's all about documenting what you do in the easiest way that you can, basically. So Ewan says, I did it, but it merged with master and not dev. That is a good point. That's something I should have pointed out. So if you create a new pull request on GitHub, it will default to the master branch because the master branch is the default branch. So you have to go here and use the drop down to select dev. Yep, no, that is a very good point, and that's a thing I should have mentioned. If you want to change what the default branch is, it's under settings and then branches and then default branch. It's entirely possible I should add that to the materials. So this branch-based Git material isn't the default Software Carpentry stuff. It's stuff we've developed at Southampton and we've run a couple of times. So there's definitely room for improvement. Yeah, so let's go back to client analysis. So it's almost 1:15, so I am just going to, well, no, okay, if people go for a break at 1:15, and then when we get back, I will walk people through what I did, and then, yeah, and then we can move on to how to deal with merge conflicts. But yeah.
Sam, do you want to show maybe a slide? So back at 10:30 or something.
Yes, back
like
at 10:30. Well, I do not have a slide for that. So
it's okay. I can do that if you.
Cheers.
I mean, if people are okay, maybe we don't have to show the slide, but it's good to remind everyone. So let me just. Maybe reverting. So Evan's error that he merged with master, not dev? Are we going to do it after a break?
So it won't make any difference to the material ongoing. So it's just a little thing to be aware of. Yeah. And the thing I should have made a little bit clearer, because you don't have to select the branch when I do the example, first of all. So yeah, that's an easy thing to overlook.
Sure. Okay, well, see you all in 15 minutes.
Great, so it's past. Is everyone back? Can I just get a yes from you if you're back? Okay, still a couple of people off getting cups of tea then. Apologies if I forget to mute my mic at any point whilst drinking tea. I will endeavor not to.
I have few questions if I can ask.
Go ahead. Yep. So what are your questions? I'm not sure if you've not unmuted your microphone or something, because unfortunately I can't hear anything.
So the thing is, in the doc file, the doc, what can I say, branch, I should have only one file, readme.md, isn't it?
You should have created a new file called readme.md that's
Yes.
added on that branch. So you don't have to delete the other files or anything, but doc should just contain one commit that adds readme.md.
I did that, like readme.md file created, but somehow I also copy the other climate analysis, rainfall conversion, temperature conversion, all file in the.
Well, so that's okay. That's what should be happening, right? So when you do a commit, you store the state of all of the tracked files in your repository at the time that you make that commit. And so when you commit to the doc branch, you're saying the current state of my repository is it's got all these files that I made in previous commits, and also it has this new file I've made. And so that's the correct behavior, because the branch is just a version of your code. If you want to remove the other files, you have to explicitly tell the branch you want to remove the other files. But it's very unlikely. You're not going to want to create a new branch that just contains a single file. But the commit that you've made to that branch, so the commit being the record of the changes that you've made, will just contain that single file, and it will just contain the change that says, I made that file. So that's okay. That's working as expected.
And I have another question.
Okay.
The last thing is, you say that merge your new feature branch back into your development branch and pull the changes dev back to your local repository.
Mm-hmm.
So first, for that reason, I go to the what can I say, dev branch. Is that the right way? Like
Yeah.
Git Checkout Dev.
Mm-hmm.
Then I try to use Git. Sorry for the problem. Where I find. Then I write git pull doc then dev.
So whilst you can do the merges on the command line, we were going to do it using a pull request on GitHub. So you go, after you've pushed your doc branch to GitHub, then you do the pull request there to update dev, and then you pull dev from the remote repository to your local repository. So the reason we do it that way is so that the record of you creating this new file is visible online for everybody else. There's a nice clear record that you made a new branch and you did this in this branch and you pull requested it in. Because if you're working with other people, it's important for them to know that. Otherwise, you can get into problems where you make a change and you silently pull it in and nobody knows you've done it. And then they're like, oh, something has changed. So I'll just share my terminal and just go through the way you, the steps that you take to go through this. So yeah, git pull origin dev is the the correct behavior because origin is the remote repository. So I'm going to do git branch to find out what branch I'm on. I'm on master. So I want to create my branch coming off of dev. And so what that means I need to do is git checkout dev and then git branch doc. So I'm on the development branch and I'm creating a new branch called doc. And now I do git checkout doc. So it's kind of annoying that you have to make the branch and then switch to it. There are shortcuts for that, which we'll get to in the next bit. And so now I'm going to create a new file. So I'm going to do nano readme.md. This is I'll use the text that I put in the exercise. Tools to parse and convert climate data from CSV. But because this is just a text file, you could have absolutely anything you want. It doesn't make a big difference. So I'm going to save the file with Control X to quit, Y to save, and Enter for the file name. So now if I do Git Status, so it's a good idea to just keep doing at least whilst you're getting used to Git, to just keep doing Git Status because it gives you a clear record of where you are, what you're doing, and the command you'll need to use. So you can see I'm on branch doc, and there's an untracked file. So this is a file I'm not checking the changes for, which is called readme.md. So I'm going to do git add readme.md, git commit -m, added a readme file. So remember, you have to add to say, I want to track this file, and then commit to say, so all of the files that I'm tracking, I want to record the current status of them. So your add is putting it in the staging, commit is recording that. And now we're going to do git push origin doc because we want to push the current branch to our remote repository called origin and give it the name doc there. So again, my username, job done. And you can see there is a new branch doc, which is based on the local branch doc. So now I will switch to my browser and go back to my repository. So doc had recent pushes less than a minute ago. So I'll just refresh and you can see here doc exists. So I'm going to look at doc. Doc has a README file. So when we just edit a file which Git is already tracking, we only commit. So if you do git commit -am, that will add and commit all of the files that you're already tracking. If you just do git commit, it will only commit the files that you have used git add since the last commit. You will almost always want to do git commit -am. There are some use cases for only committing a subset of the changes you've made, but in general, you want to commit all of the changes. So not all version control systems have this concept of the staging area because you have your workspace and you have the commits. And you can select some of the changes you've made to put onto the commit, but in general, git commit -am is what you want to be using. I don't know if we introduced that. That's a thing that needs to be, yeah, it's one of those very annoying little, once you get used to it, it makes sense. And you will occasionally be like, oh, I just don't need to commit this bit, but it's good practice to just commit everything. Okay, and so we can see doc had recent pushes less than a minute ago. So I'm going to do compare and pull request. And now I can select the branch. So I'm going to merge doc into, I click down here and click dev. So because master is the default branch, by default, it will merge things to master. We should probably I should probably add some changes to the material that say to switch the default branch. Apologies for that, but we want to merge to dev. If you merge to master, it's not a big problem because the next bit of work doesn't really use the README file, so it won't matter if you have it or not. But so now we're going to do a pull request, add as a README file. I'm just going to do a little comment, though it's a bit unnecessary. Added documentation, create pull request. And now you can see there's no conflicts with the base branch, so I can merge the pull request. Confirm merge. Pull request successfully merged and closed, so that's good. So now if I go back to the main repository and click on this down arrow, I can go to dev and I can see dev now has a readme.md file. So now I've got that updated on my remote repository. Let's sync that up to my local repository. So I will just do Control L to clear my screen. And now Git branch tells me I'm on doc. So I want to update dev. So I'm going to do Git Checkout Dev, switch to branch dev, and I'm going to do Git pull origin dev. So what this has done is it's pulled the updated version of the dev branch from my remote repository called origin. So yep, and as you can see, we have got a new file, readme.md. And if I do ls, bam. So I hope I didn't go through that too fast. Probably did. But with that done, so now we can move on to the next bit, which is conflicts. So this bit should be not so bad. So no, does anybody have any questions, by the way, before we move on? Did anybody run into any problems whilst doing that exercise?
I had one problem actually, but I think I sort of fixed it. I don't know if I fixed it in the right way. So what I did was actually, you kind of, yeah, when you mentioned it's annoying how when you create a new branch, you have to change to the branch having created it. I didn't do that. And then, everything I did was in dev, not doc. But then weirdly, when I pushed, my GitHub page then said that doc had been created like 20 minutes earlier when I'd actually only created it like 1 minute earlier, but I don't know why that was. And then when I worked out what had gone wrong, I managed to delete stuff, did a new commit in dev, then switched to doc and then redid it, and then everything works. And
okay. Yeah.
There was like an extra commit in there, and I had to quickly Google how to remove a file before doing it as well.
Yeah. Sorry about that. So
no,
this is one of those things that's a little bit unintuitive. So we teach because there's all sorts of little shortcuts and handy additions you can do to make the workflow easier. We want to teach like the fundamental what's going on before we then teach you the shortcuts, because otherwise you don't necessarily know what's going on under the hood. And if the shortcut isn't suitable, problems happen. But we are now going to introduce some shortcuts that will make life easier and avoid a bunch of the problems that people have just faced. In the name of solving conflicts. So does anybody else have any questions?
Yeah, I have one.
Okay.
Like in my dev, it is showing the README file, but when I check out to my dev and go the list of the file, it is not showing.
So remember that so when you've done the pull request online, you've merged those changes in on your remote copy of the repository. But you have to synchronize that with your local copy of the repository. And you do that by using git pull. So if you go onto your development branch on your local machine and then do git pull origin dev, what you're going to do is pull the changes that have been made to the dev branch on the origin repository to your current branch, and that will update it.
Thank you.
That's good. Any other questions? No, great. So let's move on to conflicts. So this is, oh, somebody seems to have switched off, never mind. So this is kind of what you'll get into if you when you use the feature branch workflow and you're creating different branches, you might run into these, or if you work with other people, you're almost certain to run into these. So as you mentioned, you can store changes to multiple different files, right? You can sort of have multiple different branches that change the same file. So, you know, one branch could change a function to fix a bug, another branch could change a function to update the maths, implement a new equation. But you will eventually want both of those changes. You will eventually want to have the equation updated and the bug fixed. So we want to know how to merge those changes together. So we've got one set of changes. So here you go. And what happens if we have conflicting changes? Two people edit the same file in the same place. So Git is smart. If you edit the file in different places, so one person adds a line to the start of the file, one person adds a line to the end of the file, Git will actually handle that automatically. It will go, oh, okay, well, there's no actual conflict here. You're both editing the same file, but you've done it in different places. So we can merge this automatically. So that's really easy. But if you both edit the same place of the same file, that's when conflicts start happening. So we are going to create some new branches. So we're going to create two new feature branches that come off of the development branch again. So here's the quick summary of what is going to happen. And I am going to switch back to the terminal and run through it. So if I'm going too fast, please just say Control L to clear my screen. So I'm going to do git branch to find out what branch I'm currently on, which is dev. That's good. If you aren't currently on dev, you want to do git checkout dev. So I'm already on dev, and that's fine. So now I want to create a new branch coming off of dev, and I'm going to do that using git checkout -b dev. So what this does is it creates a new branch called dev and it switches to it. So this means that you don't have to do git branch and then git checkout. It does both of those commands in one line and just makes life easier.
So just to check, you're going to have two branches called dev?
No, that's a good point. Sorry, I'm an idiot. So I checked out dev. Now I'm going to create a new branch coming off of dev, and I'm going to call it feature centimeter. Thank you for that. This is the perils of working in the mornings on Fridays. So we're going to do git checkout -b feature centimeter, because at the moment the code only converts inches to. So if I tried to do that, by the way, Git would have said you can't do that. There's already a dev branch. So you don't need to worry about accidentally doing that. But thank you for calling me out on that. So git checkout -b feature centimeter, because we have a function that converts inches to millimeters. But what if we also want to convert inches to centimeters? Why would we want to do that? Well, we're going to do it anyway. So switch to a new branch, feature centimeter. And now we are going to do nano rainfall conversion.py. So I did nano RAI and then tab to complete the file name. Now we're not going to actually go to the effort of writing a new function. We're just going to put a comment into the file that says hash to do add function inches to centimeters. Why can't we just divide or multiply the result of inches to millimeters instead of bothering adding these extra functions? Nobody knows. So once we've added that, so I'll just wait a little while for everybody to open the file and type that in. But again, it doesn't, the important thing is we're adding a line at the end of this file. It doesn't have to have the exact same text as what I've written. just get the idea across. So I'm going to do Control X, Y to save, and then Enter to save to that file name. And now I'm going to do Git Status to check the state of my repository. So we've modified rainfall conversion.py. So as you can see, the message at the bottom, no changes added to commit, use git add and or git commit -a. So again, Git Status is a really good command to get into the habit of using because it tells you the branch you're on, what files have been modified, and the commands that you need to use in order to do the basic things you're going to want to do every day with those files. So in this case, I'm just going to do git commit -am, and I'm going to say added placeholder for centimeters. So now we're on a new branch called feature centimeter. We've changed one file and we've inserted 2 lines. So one of those is the blank line. One of them is the line with the placeholder. And we are now going to do git push to get this change up onto our remote repository. So we're going to do git push -u origin feature centimeter. So what the -u flag does is it sets the default remote. So what we're saying is when we're on this current branch, so when we're on the feature centimeter branch and we use git push, by default, we're going to want to push to origin and to feature centimeter on origin. So if we use -u, then every time after that, if we want to push to origin feature centimeter, we can just use git push. So we're just setting the default. And this is important because if you have to type it out every single time, you increase the chance of you making a typo, and typos cause problems. So git push -u origin feature centimeter, and again, username and password, and we can see we've got a slightly different bit of output here, which is branch feature centimeter set up to track remote branch feature centimeter from origin. So what that's saying is we've just linked feature centimeter locally and feature centimeter on origin. And so git push and git pull will just by default go back and forth between those two. So that's really handy.
Just very quickly, when you had the commit before, there was the -am/ bit option. That's presumably the one that puts anything new on the staging and then commits it all in one command.
Yeah. So any file that you've already told Git that you are tracking, git commit -am will add to the staging and then commit. So if you've made a new file, git commit -a won't include it. You're going to have to call git add. But otherwise, any file you've already told Git that you're interested in tracking, it will add to the staging area and then commit.
Thanks.
Yeah, it's just because it only works on files that you've already told Git you are tracking. If you've added anything new, it won't include that. So now we've done that, we want to create a second new branch so we can set up a conflict. So can everybody just hit yes if they have managed to get this far? And if you haven't got this far, please just unmute and say what your problem is, or just post in chat. Okay, 5, which I think is the number of people with the working feature, at least as far as I know. So we can move on from there. So just checking, everybody else, the people who haven't ticked, you are definitely up to speed, right? Because I'm going to be making 2 branches and setting up a conflict, I really don't want to get people out of sync. Okay, that's 7 ticks, thanks. Yeah, it just, this is the thing. It just really helps me to know how people are doing. So that's good. And are you happy with the speed? Should I be going a little bit slower or a little bit faster?
This speed is good.
Okay, brilliant. So we have created one new branch coming off of dev. Now we want to create a second new branch coming off of dev. So we do that by Git Checkout Dev again. So what this is doing is switching us back to the dev branch, and Git tells us switch to branch dev, and Git Checkout -b feature meters, because we've created one placeholder for converting inches to centimeters. We're going to create another placeholder for converting inches to meters. And we're going to create a new branch for this with Git Checkout -b. So switch to a new branch, feature meters. And now if we do nano rainfall conversion.py, so nano rai tab, enter, we can see we've gone back to dev where there is no extra line added to the end of the file. So what we're going to do now is we're going to do...
Sorry, I missed your last command there, Sam.
So did you do the Git Checkout Dev and then Git Checkout Feature Meter? Checkout -b feature meter.
Checkout -b feature
_m.
Oh yeah.
So we're creating another branch coming off of dev. So we've gone back to dev and we're saying, okay, actually there's another feature I'd like to add to dev, which is the conversion from inches to meters. So I'm going to create a new branch that will do that.
Thank you. Okay, got it.
And I'm going to, yeah, so then it's nano rainfall conversion.py, and I'm going to add a to do. So sorry about that, a little bit of a cough. Not COVID. And the to do is for add inches to meters. So we're going to add a new file. We're going to say we're going to add this, and it's a new line at the end of the file. But the problem is this line is in the same place as the edit we made on the feature centimeter branch, right? So what's going to happen when we try and do pull requests? So I'm going to Control X to X out of nano. I'm going to use Y to save, and I'm going to use Enter to write to file. And now Git status. So yeah, we've modified rainfall conversion.py, and we're on the branch feature meter. So I'm going to do Git Commit -m added, sorry, Git Commit -am added placeholder for feature m. And so, yeah, we've modified one file. So now if I do Git status, you can see we're on the branch feature m, nothing to commit. So we're all up to date. All of our changes are being committed. And now I do Git push -u origin feature _m. So we're going to create a new branch on our remote repository called origin by pushing the current branch, and we're going to link the two together so they automatically go back and forth. Well, no, they don't automatically go back and forth, so that by default, they go back and forth. So git push -u, and again, username and password. If you get sick of having to type in your username and password all the time, you can use SSH keys to sort of identify yourself automatically. This is why when we created the repo earlier, we had to make sure we checked HTTPS, because that's the way you connect by entering your username and password, and it's the easiest thing to set up. But in the long term, you might want to switch to SSH. Great, so...
Sorry, Sam, I'm a little bit behind. I've just done the git commit line. What were the ones after that, sorry?
So after you commit, so I did git status to check that everything was fine. So if you just do git status. Do you get the same output?
I do, yeah.
Brilliant. So now you do the same git push command that we did earlier, but this time we're going to feature M.
All right, thank you.
Brilliant. So now we've done that, let's go back to GitHub. Let's go back to slides. So we've done the branch 1 slide, branch 2 slide, pull requests. So create a pull request from feature centimeter to dev, and then another one from feature meter to dev. So let's go back to our climate analysis repo. I'm going to hit refresh. So feature centimeter had pushes 9 minutes ago, feature meter had pushes 2 minutes ago. So we're going to merge in feature centimeter. So compare and pull request. Okay, and this bit is important. So we're going to merge this to dev. So we can automatically merge feature centimeter into dev using a pull request. That's brilliant. So I'll just wait for everybody to open a pull request for these two. So again, make sure it's feature centimeter to dev. And with those set up, I'm now going to click create pull request. So add a placeholder for centimeter. So I'm just going to click on files changed. And you can see we've added one line to the end of rainfall conversion.py. Everything is brilliant. So I'm going to go back to conversation. This branch has no conflict with the base branch. Merging can be performed automatically. So that's brilliant. So in that case, I'm going to click merge pull request. And I'm going to confirm the merge. Ta-da! So now I'm going to go back to the main page. And feature meter had recent pushes 4 minutes ago. So I'm going to do the same thing, compare and pull request. I'm going to select dev because it's important that we do merge both branches to dev. And now we see can't automatically merge. Don't worry, you can still create the pull request. So if everybody can just hit yes once they have gotten to this point and it's saying can't automatically merge, or just unmute and talk or post in the chat if you haven't gotten this far and you're having difficulties.
Sorry, I missed that last step. I did the merge into dev, and now you've just done something else. I missed what it was.
So I did a pull request from feature centimeter into dev that it could automatically merge. And so I was like, great, I'm going to confirm that merge. And then we've got our other branch, feature meter. So I created a new pull request from feature meter to dev. So I went back to the main climate analysis page and I clicked on the compare pull request button for feature meter. You can also do it through the pull requests tab here, but the nice big button is the easiest way to do it.
Ah, okay, I see, sorry.
Great, that's right. So everybody else, I've only got 3 people with ticks so far. Six. So is anyone else having difficulty or a bit behind, needs a little bit of assistance? I think we had 7 was the high water mark we reached. 7, brilliant. Okay. So we can't automatically merge these two. Something we've done in feature meter conflicts with a change in dev. We can't automatically merge the two, but that's okay. We're going to create a pull request anyway. So create pull request. And this branch has conflicts that must be resolved, and the conflicting file is rainfallconversion.py. So I'm just going to show you, you can actually resolve the conflicts through GitHub. If it's a small conflict, one that isn't too big, GitHub will allow you to fix it. So I'm going to click resolve conflicts, and you can see here we've got the file, and we've got this stuff here where we've got a bunch of arrows. Oh,
how you go there? Would you please tell me from the page from where it cannot automatically merge?
So when it says you can't automatically merge, you go down to create pull request, and that should then give you, I'll just clear the statuses, and that should then give you this screen where it tells you that the branch has conflicts. So we've tried creating the pull request, but there's conflicts. So have you managed to get past that bit?
Yes, sir.
Brilliant. So we're now going to click resolve conflicts. So because this is a small conflict, and we're lucky, it's all in one file. So you can see here that there's this bit highlighted in red. So this is the bit where there's a conflict. And you've got these row of equal signs in the middle, which indicates the bit where the conflict is occurring. And we've got, so the bit at the top shows you the changes that were made on the feature _m branch. So there's the to do, add inches to meters. And then below that, there's these arrows that say the changes that were made on the dev branch, which is add function inches to centimeters. So this is a text editor. So you can resolve the conflict online by just deleting the bits of code that you don't want, by deleting or fixing the conflict there, and deleting the markers around the outside. However, if you do that online, you don't then get the chance to like run it locally and test to make sure that your fixes work. And also it's only possible for us to do this because we've set up a really simple, really kind of basic toy conflict. In the real world, your conflicts are quite likely to be bigger than this or more complicated than this, and you won't be able to solve it. You're not guaranteed to be able to solve it through GitHub. Also, I don't think GitLab has this feature. So what we're going to do is we're going to learn how to fix the conflicts ourselves. So the way we're going to do this is we're going to update feature meter to contain the changes from dev, because the reason we've got this conflict is because there have been new changes, new commits made to the development branch since we branched off with feature meter. We need to update feature meter with everything that's happened in dev, and then we should be able to merge it back in, no problem. And so what is the way we do that? We use git pull. So we are going to go back to our terminals, and I'm going to do Control-L to clear my screen. And so I'm going to do git branch to check out what branch I'm on feature meter. That's good. So make sure you're on feature meter by using git checkout feature meter. And so we want to update feature meter with the changes that have been made to dev. And currently those changes exist on our online repository called Origin. And so what we are going to do is git pull origin dev. So we are pulling the changes from our remote repository Origin, from the dev branch there, into the branch feature meter. So previously we've only used pull to update, the same version, to update our local branch to the remote version of the same branch. Today we're updating it, now we're updating it with the remote version of a different branch. So this is one of the really handy things Git can do, and we're just going to pull origin dev. And it gives us a status report, and that status report is it's trying to automatically merge rainfall conversion.py, but there is a conflict in the contents of rainfall conversion.py. So we have to fix the conflicts ourselves and then commit the result. So can people give me a tick once they have got this error message? Seven, great. And the people who don't have ticks, have any of you run into a problem? You're all still up to speed? Okay. So now we are going to have a look at rainfall conversion.py and try and fix it. So nano rainfall conversion.py to edit it. And we can see basically the same stuff as we saw online, right? When we looked on GitHub, we can see the bit where we've got these markers for the changes that have been made. So head refers to the changes that have been made in our current latest commit in the branch that we're on. So we're on inches to meters, and so this says this is what's in the latest commit on inches to meters. Somebody has messaged me. I'm confused now. But actually, the commit we've just tried to pull in has the line add function inches to centimeters there instead. And we've got the ID of that commit. So remember the IDs that we went through earlier, they're a way of identifying a specific commit. So this is the same information as we got on GitHub when we were doing it, and it said feature meter and dev, but it's more precise but less helpful, as you often get with computers. So GitHub goes more out of its way to make sure that it's easy to use. So now we're going to resolve this. Well, actually, we want to keep both of those placeholders. So if there were two conflicting versions of the code, say you had the same equation implemented in two slightly different ways, you'd want to delete one of them and then all the markers. We're just going to delete the markers because we want to keep everything. So I'm just going to delete all of the arrows and the equal signs. And because I've noticed that I wrote this slightly differently, I'm going to add the word function here. Add function inches to meters, add function inches to centimeters. That's just pedantry on my part. You don't need to do that. The important thing is that your code should have 2 lines of text and none of the arrows and equal signs, just comments. So I'll just clear things. And if people can tick once they have managed to remove the conflict markers and we've just got the to-dos. Okay, so the people who haven't managed to tick, so do you mind saying what problems you're encountering? Oh, you missed the command to open the conflicted version in Nano. So we just open it the same way as we open a file, normally with just Nano and then the name of the file. So yeah, there's nothing special about this conflicted version. It's just taken the file that the conflict is in and just edited it to add markers. No new magic extra files have been added. It's just put those markers in. But yeah, and kind of one of the big advantages of Git adding in those markers to that specific file is if you then try and run the file, there's basically no language in which that's valid code, and so it will crash And so you will know that, oh, whoops, I didn't finish up my merge. So that's important. We don't want to commit files with these conflict markers in, and Git should complain at you if you try to, but that's not guaranteed. So we've now got 7 people who have this file up to speed. So we are going to do Control X to quit. We're going to press Y to save, and we're going to press Enter to save to rainfallconversion.py. And now Git Status. I'll just clear the thumbs up. So unmerged paths, use Git Add to mark it as resolved. So we're going to do Git Add rainfallconversion.py. And now we are going to do Git Commit -m fixed the conflict in rainfall module. So we now have a new commit in our feature meter branch that fixes this conflict, that makes it so that feature meter is now fully up to date with all of the changes in dev. And now we are going to do Git Push. And because we used Git Push -u earlier, we've set the default. And so if we do Git Push, this will just push from the feature meter branch to the feature meter branch on our remote repository. Ta-da! Everything is good. And so I will now just wait a little while for people to do that. So you'll notice that we've fixed this conflict on our feature branch. So if we wanted to, we could have checked out dev and we could have done git pull, origin feature meter into dev and then fix the errors in dev. That's a thing you can do, but it's also kind of a bad way to do it, because if it turns out that fixing this conflict up takes a lot longer than you thought, now your development branch is kind of clogged up with unfinished code and you can't do any bug fixing on it. You can't do this or that. So when in doubt, try and fix things in your feature branches. It's particularly important if you're working with other people because, raised hand.
Hello, sorry, I didn't want to just interrupt. I've managed somehow to obviously sync the wrong repository or merge the wrong repository in GitHub, such that now, having done this edit in the terminal and trying to push it back again, it's now giving me an error that they're out of sync and refusing. Does this matter, or can we just can kind of continue?
Can you share your screen so you can just have a little look?
Yeah, hold on a minute.
Alex, can you make him a co-host so he can?
I can, yes. Just a second.
Sorry, I didn't want to hold this up unnecessarily. I was just wondering whether it was important or not.
No, it's important to get every question answered.
Oh, what's that? No. So what's going on? Sorry about this. What was I doing? Oh, there we are. Okay. You getting that?
No. Yeah, I'll just stop sharing and see if it'll. Yeah, so we can't see your screen.
You
Could
can't.
you?
All right, let me try again. Is that right? No?
Okay, so you're trying to push from feature M to feature M. Updates were rejected because the remote contains work that you do not have locally. So what that sounds like to me is that when you So can we have a look at your pull requests, please?
There, pull origin.
So Git pull origin dev. So Git status. So new file readme.md. Yeah, that should.
I think it might be something I've done in GitHub rather than here, like
so
sync the wrong repos in the wrong way, because it was
yeah,
sort of getting a bit lost.
It might be that you've merged feature center meter into feature meter instead of into dev.
I think I did both actually.
Oh, so you merged into dev and into feature meter.
Yeah, sorry, I thought that's what we were doing.
No. So in general,
Okay.
you merge your feature branches into dev and dev into feature branch. You don't normally go between these feature branches because otherwise you get these kind of these weird bugs where things end up out of sync. So yeah, so we would just trying to update dev from the feature branches. So in this case, sorry, if you just scroll back down to the bottom, try git pull. Okay, so now you're going to have another merge conflict. So just open rainfall conversion.py.
Okay, so just probably
yeah. So
oh dear, I keep getting caught out by the fact that the Windows cursor isn't. Like you don't know if you see my cursor or not, but it doesn't actually do what you think it's going to do.
Yeah, the ones with the command line.
Yeah, so you can highlight stuff like that, but then it doesn't actually delete it if you press delete. I don't. Oh, no, it doesn't work either. I'm not sure what the purpose of the highlighting is in this editor. It doesn't actually do anything.
Oh no.
Right.
Okay.
Okie dokie. Right. Thank you.
So now you've removed all the conflict markers, so it's going to be fine. And so now you can do git add and then git commit again.
Yeah, mine's yeah. Oh, not that.
So this is so if you do git commit -m, what you're adding next is the message that you're going to have.
Oh no. Oh right.
Commit. So at the moment, the message is just rainfall conversion.py. So ideally, it should be like a string in quotes where you describe what it is you've made. So git add, you are adding files using the file name. Git commit, you're saying everything I've added, I'm going to commit it with this message.
That'll confuse me later. I guess I can't change that now.
Yeah, it doesn't matter. It's not a big deal. Right. So I think then you're up to speed there. Okay. So
did he do the push? Hold on.
Oh yeah, git push. Ta-da! So Thank you. That's worked fine.
Thanks everyone. Sorry.
Just no, it's okay. It's useful to see what happens when these things go wrong. So now let's go back to our GitHub repos, and I will do that with where is the screen share? Come on, Zoom. The perils of having so many windows open. So I am back on my repository. So I've gone back to the main page, and I'm going to go to pull requests. And here you can see the list of pull requests that are open. You can also, if you want, click on close to view the pull requests you've done and that finished. And so I'm going to click on this open pull request. And you can see if you scroll down, now there's no conflict with the base branch, and we can automatically merge it. So I'm just going to click merge pull request. And then confirm merge. And that is good. So now dev is up to speed. And so what I'm going to do is I'm going to go back to my terminal. And I'm going to do Git Checkout Dev. So I'm back on the dev branch, and I'm going to do Git pull. And because I want to set it up to do this automatically, like I have with the other branches, I'm going to do Git pull -u origin dev. Cool. I've already done that. No, sorry, you use Git push -u to set the upstream. That's annoying. So great. We now have dev up to date. With our edits to rainfallconversion.py, and now if we want to make a new branch, we can just branch off of dev and make our new changes. And that is basically it for branches. You've basically been taught how to check out dev, how to create a new branch, do your work on it, and merge it back in, how to have multiple branches that will make different changes, even to the same files, and merge them back together. So
that's one quick question. Sorry. So on GitHub, it keeps suggesting we might want to delete these branches, which makes sense. Now you've explained that you have the sort of main branch, the dev branch, and the feature branches. If you did delete that on GitHub, how would that, presumably that wouldn't, how would that sync onto your own copy? Presumably you've still got a local copy of this feature unless you...
Yeah, you'll still have a local copy. So basically all that's doing is deleting you'll still have all of the commits that occurred in that branch because they've now been added into your dev branch. So they'll still exist. And you can still recover the history. You can still figure out which commits occurred on which branch by looking through, but it's a lot easier to do it by just being able to like go to the main page and look at the list of branches. There are command line commands to delete branches in your local repository. So in general, I would advise against deleting branches just because...
I think Alex has just disagreed with you.
Really?
Unless I've misunderstood what she wrote.
I said good practice is to clear merged branches on GitHub because create clutter, but you can keep them. Okay, I'll leave it to the real experts.
No, I don't. I think we're sort of on a level playing field here, or you're the more experienced person. But I personally avoid deleting branches unless they're a very small branch, or so realistically you can delete feature meter and feature centimeter because they only have one commit in it. Doesn't matter. But personally I avoid deleting branches just because I like to have a clear record, and it can kind of be easier to switch back to a branch. Like quite a lot of the time you will end up wanting to recreate branches like, okay, actually no, I've got this one particular bug on this feature that I want to fix. I know it's the reason not to do it is clutter. So it kind of depends on your tolerance of clutter and how much value you place on kind of having an easy way of looking back at what you did to implement any given feature or what you did to fix any given bug. So it's a personal preference thing, really.
Okay.
Okay.
But I'll just to actually delete it though. So you've obviously deleted it on GitHub, but it still sit on your local machine, presumably.
Oh, I think it's git branch -d.
Oh, okay, so you manually delete it on your local side.
Yeah.
Yeah. Okay, no, that's fine. I just wasn't sure. Thank you.
So they do take up space on GitHub, yes. So on GitHub, if you want to, yes, reduce the amount of branches, you can do it, and you can still keep them as your local branches. If you fully sync your local copy with the GitHub where the branch is deleted, and some correct me if I'm wrong, it will actually delete the branch locally as well. If you do git fetch or something, it will would it then sync the deleted branch as well and actually delete it on your local?
I can't remember because I don't often use git fetch. I normally
don't often use git fetch, but git fetch is, yes, git fetch all brings all the branches in sync with the remote repository. And I'll stop talking now because there was some other comment from someone.
Okay, before git pull origin dev, what's the code you write? What's the command line you write?
So I switched back. There's a bit of a lot there. So previously I did Git Checkout Dev and then Git pull origin dev. So you can use Git Push -u to set a default to say, by default, whenever I use Git Push or Git pull, I want that to refer to the origin repository and the dev branch on it. For no particular reason, Git doesn't let you do that with Git pull, I guess because you're more often going to want to pull from different branches. It's very rare that you will want to push to a branch that is not your like default branch. But it is, as you've seen, we use Git pull to pull from branches to do merges. And so I guess letting people accidentally set the default as the wrong branch is a bad idea. So yeah, I was just trying to do something which Git push can do, but Git pull can't.
Okay, thank you.
So yeah, so did everyone manage to get their dev synced up? If you just hit the tick, if you have, and then so the people who haven't, have you run into any particular issues? Great. So that is all the stuff on branches and conflict resolution. We've got another about 5 or 10 minutes worth of stuff on git ignore files, which we can cover after the break, or if we don't, we could cut it short early. Alex, what do you think?
I think maybe having a break is now a good idea, okay. And then do the last 10 or 15 minutes. And then people can ask questions as well. And then we can finish early. I've got one last slide to show to wrap things up as well. So, but that's not going to take more than 5 minutes. So yes, maybe stretch your legs a bit and then come back. So now it's 11:35. So 11. So 5 to. No, sorry, what am I saying? 10 to 12, is that right?
Yeah.
So 11:50, back at 11:50, everyone.
Great, right. See you all then.
See you in a bit.
Okay, it's 11:52 now. So I hope people have had enough time to get cups of tea or what have you. This next bit should be pretty short. So somebody is asking a question in chat about privacy. So if I have a private repo, is it okay to have data on there, which is like MRI data? I would, oh, have I got my camera on? I should have my camera on. Ah, yeah, the light is on. Okay. Yeah. So I would not commit data to GitHub. GitHub is for code. You should you should describe the data you expect your code to run on, but I would not commit data files to GitHub, especially not data files or not commit data files to your repository full stop, because you can't like only sync commits to some files up. So don't commit data files to a repository unless you've got very good reason to. Even if you're going to be syncing it remotely to a private repo, or even if it's a repo that will only ever live on your computer. Yeah, I have a large file storage GitHub. So I have not played around with that. I'm assuming it's a new feature. Alex, do you have any experience with this?
Let me have a look. So I think if it's too big, I don't know what's the current limit for storing big binary files in GitHub. There is a limit, but I don't know what it currently is. So there is possibility that you can't actually do that at all. There are always other file storage facilities that you can store your files on the cloud somewhere.
So looking at Git large file storage, it looks like it's a way of getting around the file size limits by using symlinks essentially. So I've not played around with it.
I've not either. On the topic of storing data, I personally store the data in GitHub, but obviously the data should not be private. So you should only store data that you're happy for everyone to see and that you're happy to share. So if your data contains private information, if you have some email addresses or something like that, or some identifiable information, I wouldn't do it. But I normally store my spreadsheets, my CSV files in GitHub just because it's, well, convenient. And you might need that data anyway to run the code. So if you clone your repository from some other location, you want access to the data as well. But that's just me. So you would have to make your own decision based your individual use case, whether you want or not to store your data. And then for the big data storage, again, I don't have experience, so I can't answer that, unfortunately.
So I think my perspective might be colored a bit by the fact that I was once given a not huge, but a data file that was large enough that I couldn't manually go through and check everything by somebody, and was told it was basically fine. I was like, okay, right, I'll just add that to repository. And then when I started analyzing it properly, it turned out it contained plain text passwords. And removing a file from your Git history is non-trivial. Like, there are tools to do it, but it's a bit messy. And even on a private repository, you don't want to have plain text records of people's like names and passwords. That's insane. So yeah, if you're absolutely sure the data is safe and you don't have any problems, then that's good. But it might depend on the extent to which you trust your collaborators and data sources.
I have to say I was guilty once of committing my password to use some service. So normally I would have a local file where which is ignored, and that I keep my password in, and then that it's read by the code to authenticate to a certain service. And then, I don't know, what was that? In the moment of wisdom, I thought, why is this file ignored? So I added it and committed it to GitHub. And there you go, my password was there. And as Sam said, because Git keeps a history of all commits, even though you delete the file, it is still present in some of those commits in the past. So you can dig it out, and then you would probably have to do loads of magic to remove that commit from the Git history. And that commit might contain some other files as well. So you don't really want to revert that whole commit. You just want to get rid of that file that exposed your password. So yeah, do be careful with these things, especially because by default, GitHub repositories are public, but even if they're private, you would still expose the data that you don't want to.
So hopefully you will never have to deal with that.
Hopefully you won't do stuff that I've done.
Yeah. Right. So, unfortunately, Alex talked about ignoring things, so we can move on to Git ignores, which will be a nice, quick and easy roundup. So, ignoring things. So basically, what if you have files in your directory that you don't want tracked, that you will never want tracked? Say it is, like a 10 gigabyte data file that your code runs, or what if your code is a simulation code and it outputs, megabytes and megabytes of WAV files? You will not want to store those on Git, particularly for things like binary files, like a WAV file. Git can't really do version control on them. It can do version control, sorry, but it can't do smart version control. It won't store the differences between versions of files. It will just be like, well, this file is different. I don't understand the detail of it because it's not a text file, so I'm just going to have to store this whole new copy of the file. And you can very rapidly end up with very large repositories if, every time you run your code, generate a new data file, you end up adding that copy of the data file to the repository. So again, this might be a thing where people are coming from different perspectives, because I'm coming from the perspective of writing simulation codes that output gigabytes of data, for example. And for me, if I stored that in the repository, it would very rapidly just jam the whole thing up. So just, my disk would be full. So we're going to use git ignore files to get around that. And the key bits of files are git ignore and git keep. So we are just going to switch the terminal and go through how to use them. So this will be nice and simple. I'm just going to use Control-L to clear my screen, and git branch to make sure I'm on the dev branch. It doesn't matter which branch you're on at the moment, but for the sake of ease, we're going to do this. And actually, I'm just going to do, I think it's git branch -D to delete the local branch. Yeah, there you go. So if you want to delete branches, like Alex said, for the sake of tidiness, you can. I do most of my development in an integrated development environment, so I don't often call git branch from the command line. I use PyCharm, which has fancy features for managing branches, and it will hide branches that you haven't used for a while. If you do it all in the command line, yeah, I can understand you wanting to delete branches more often. But so we are currently on the dev branch. We're going to make sure we are Git Checkout Dev, already on dev. And now we are going to add some files that we don't want tracked. So how about some data files and some input files? So we're going to use touch. So what touch does is it creates an empty file, or it updates the last modified date on a file if it exists. So we are just going to use we're just going to use touch to create a bunch of fake data files. So we're going to have a.dat and b.dat. And we're going to create a fake output file, which is going to be called, oh no, I've got this. So we're going to do, yeah, touch a.dat, b.dat. And so we've got them in this directory, so we can see with ls. And we're going to use make directory to create a directory called results. So we're going to imagine that this is the directory that our code is going to output to. So it's going to be reading the input files a and b.dat. It's going to output to a results directory, and the example results files are going to be things like touch results a.out. So can people just give me a tick once they have got an a.dat and a b.dat in their code directory, and they've made a results directory and put an a.out in it?
I have a question.
Okay.
What is touch doing in the a.dat and b.dat file?
So touch just creates an empty file. If a file doesn't exist and you use touch name, it just makes an empty file. We're just doing it because it's easier than using like nano to create fake contents of every file. We're just using it to make some demonstration files, basically.
Okay, yes. Then what's the mkdir results doing?
So if you remember from the shell lessons you had earlier in the week, mkdir is make directory. So we're making a new directory with the name results. And because that's a directory, then we can create files within it. And so that's why we do touch results / a.out. So yeah, I think touch is a new command. Hopefully the rest is just like reiteration to help you remember the stuff that you learned in the shell lessons earlier in the week. So now we've done that, we will do Git status. So Git status tells us we're on the branch dev, but there are untracked files, a.dat, b.dat, and there's the whole directory results, which contains files that aren't being tracked. And it says git add to include what will be committed. But we are never going to want to add a.dat or b.dat. Maybe they contain, yeah, personally sensitive information. Maybe they're 2 GB in size, and the results directory, unless we have a very good reason, or you know, the specifics of our code make it useful, we don't want to commit the results of result, the content that's in results. So how do we get rid of this annoying warning? What we do is we create a git ignore file. So we're going to do nano.git ignore. And so this basically is a list of patterns of file names that Git will ignore. And so we are going to say star.dat. So if you remember from the shell earlier in the week, star is a wildcard that matches any number of characters. So what we're saying here is
get rid of.
Yeah, so ignore any file that ends in .dat. And we are also going to ignore the entire results directory. Anything in the results directory, we don't care about it. We are never going to want to track it. And so we are going to do Control X. So I'm just going to wait a little bit for people to write that down, I guess. So now Control X, Y to save, enter to save as .git ignore. And now if I do git status, you can see the .dat files have gone. There's only .git ignore, which is untracked. And we do want to track it, so we're going to git add it at some point. So git add dot git ignore. So I did dot git I and then hit tab. And now git commit -m added git ignore file. And that says we've created one file with 2 lines. And now if we do git status, nothing to commit, working tree clean. So it's telling us the repository is now everything in this directory that we might possibly want to track is being tracked, and it's all up to date, and there's the version of it in that directory matches the version in the last commit. So can I get a tick from everyone when they manage to get that? Brilliant. So what happens if we then try to add a file that we've told Git we're ignoring? So let's do git add a.dat. It won't let us. The following parts are ignored by one of your git ignore files, a.dat. We can see which files are being ignored with git status -- ignored. And that prints out and tells us, yep, we're ignoring a.dat, b.dat, and everything in results. So that's good. There is, however, one reason we might want to use git add -f. And that is, so we've said we're ignoring the whole results directory, right? Which is great. But what if our code will always output to the results directory? So Git won't actually, the repository, when we check online, there will be no results directory. Git won't store an empty directory. But if our code always tries to output a file to the results directory, then if somebody tries downloading our code from online and then runs it, the code is going to say, well, I can't output to the results directory because this directory does not exist. Where is it? And that might confuse the users. They might not necessarily realize that all they have to do is make a results directory. It can be a bit confusing. So we are going to introduce a git keep file. So a git keep file is just an empty file titled .git keep. This is basically the opposite of .git ignore. So we're going to do touch results / .git keep. So we're just making an empty file with touch. So you could make the empty file with nano or a text editor of your choice. In this case, because it doesn't matter what's in the file, we just want to have a small empty file. We're using touch. And so we've made an empty file called .git keep in the results directory. And we are going to do git add -f to force add to override our ignore list. And we're going to say results / .git keep. And I'm going to hit enter. And now if we do git status, we can see, yeah, so we've managed to override the ignore file, and we've added a .git keep file into results. So because it starts with a dot, it's invisible. So if we just look at the results directory with ls results, all we see is a.out. But the directory will be kept by Git. Git will remember that this directory exists. And when somebody clones the repository to their own machine, they will get a copy of the directory, a copy of the repository, including that directory, but that directory will just look like it's empty. So yeah, and that is Git ignores and Git keeps. So does anybody have any questions about them?
Sorry, just quickly, I was just checking, wondering what the precedent was in terms of, precedent ranking or priority, I want to say. So you've got there, you've got git keep, you've got git ignore, and you've got a sort of manual override there as well. And I was just wondering what the kind of order of precedent is, which overrides which.
Git keep is kind of not special, basically. It's just because it starts with a dot, it's invisible. And because we force added it, it overrides the git ignore. So I think you could have anything as the name of it, just as long as it starts with a dot, it's going to be invisible. By convention, we use git keep. So there's nothing special about the name git keep. It's just the fact that we've done add -f to force it to be added regardless of what.
Oh, so it's not actually, I thought it was another instruction file, but it's not.
No, it's just
an example.
This is why we use touch. It's just completely empty. There's nothing in it apart from, just the fact that it exists. It exists and it's invisible unless you do ls-a.
So you could call it anything. Is it just convention to call it git keep?
I think you could call it anything. It is, and I think it's just convention to call it git keep, though Alex could correct me on this if I'm wrong.
So what is it? What's its purpose? Is it an example, or is it, I'm a bit confused.
So remember I was talking about how if you have a directory with nothing in, Git will not store it in your repository.
Right. Okay. Sorry.
It'll just throw it away. It's like, well, we're not tracking anything here, so let's just bin it. But yeah, then somebody downloads your code and your README instructions are, please put all of your data files in the data directory. And they're like, but there is no data directory. What's going wrong here?
Thank you. Sorry, I missed that.
So it's just a way to put an empty file in a directory so that Git will actually start tracking that directory. You can see that from GitHub as well. If you try to create just a directory from the GitHub interface, it's not going to work. So the trick is actually to create this empty file called git keep in the directory that you want to create. Maybe Sam can show you that. Sam.
Sorry, I understand now.
Is that okay?
Yeah.
I mean, we can have a look at it at GitHub. I can show you that, or Sam can.
No, that's fine. I just misunderstood what we were doing. Thank you.
Just we might as well just do a quick thing just to check. So you can do, so GitHub lets you do development directly on GitHub because it does everything. So we can do add file, create new file. So it's not a thing you would generally want to do. So at the moment we're committing directly to master. This is a bad idea, but it's just an example. And so if you want to create a file in a new directory, so it's going to have to be, say, data input.dat. And you can see by putting that slash in there, I did data / input.dat. It's created a new directory. Or if I want it to be invisible, I can do data.git keep. The contents are unimportant. And I can commit file. I'm going to select create a new branch for this commit because don't commit directly to master. So propose new file. And yeah, this is just how to create a new file on GitHub.
So it's a trick to create a directory.
Yeah,
with an empty file. So the trick is to use a file so that Git will create the new directory as well. New empty well, it's not empty because you have this .git keep file, but hopefully,
thank you.
You see what it's trying to do.
Yeah. And then there was a message in the chat. What happens if you write .gitignore in your .gitignore file? It will ignore your .gitignore file. It will not suggest you add it to the repository, but that then means you are going to have a separate .gitignore. You're going to have to write a new gitignore every time you copy the repository, and they might end up out of sync, and people might end up adding files to their version that their .gitignore doesn't block. And then you're stuck with that file. because, you know, it doesn't, because they've added it. So that overrides the fact that your git ignore says, I don't care about this. So there's not really, almost no situation will require you to do that. If you do need to do that, you're going to have spent enough time with Git that you don't need us to teach you it, basically. So yeah, do you all have any other questions about Git keeps and Git ignores, or any of the material covered in the course so far? Because obviously we've gone over a lot of stuff, some of it perhaps a bit faster than I should have. So I'm really happy to just go over anything or answer any questions. So it looks like, our GitHub in our local machine equals in terms of authority, etc. Yeah, there is no, so some version control systems have the concept of a central repository, and what you do is just kind of going to that, but there's one canonical, this is the official version. That's not really, every repository is the same in Git. So yeah, it's peer-to-peer. There's nothing is the official one. But GitHub or GitLab or what have you is basically, will be your hub. And you can do things on GitHub like manage access. So for example, this is a public repository, so it's public and visible to anyone, but only I am allowed to commit to it. So if I want, I can invite collaborators and give them different rights. So they might be able to make commits, but not change the settings, or they might only be able to commit to certain branches. So yeah, so if you're in a part of a big collaboration or working with like an open source code, you're likely to be able to say, oh, I think I fixed a bug. Here's a new branch, like feature bug fix or what have you. But you won't have permission to merge that into dev on GitHub. You could always merge it into dev on your local version of the repository, but then your local version will get out of sync with the remote version. So yeah, sometimes some repositories, you won't be allowed to do anything on the repository apart from fork it. So forks are where you basically take somebody else's repository and make your own little copy of it that you can do whatever you want on. And then you can even submit pull requests between a fork and the original version. So some projects might have everybody working on their own fork and then doing pull requests back to the central one. That's a more advanced workflow. Everyone else satisfied with their understanding of Git?
I hope so.
That's good, because I'm not. It's always introduces new things and new little quirks. So
I will understand when I will working alone. On that time, I will understand how much I get from this lesson. That's
good. Yeah, it's this should hopefully give you like a good basis for using Git, and hopefully by using the branch stuff we've taught, like a good workflow. But yeah, that's it. So I think if nobody else has any questions, then we can, future lessons. That's a question for Alex.
Future lessons on Python or other programs. So the Software Carpentry workshop that you've just attended is, I can probably actually show my slide and show you some other lessons. This is the Software Carpentry workshop there is a version for R programming language as well. And there are some other lessons within the Software Carpentry lesson material, but it wouldn't be advanced Python or anything like that. So what the Software Carpentry workshops give you is the basic introduction to these tools, such as Shell, Git, version control, and Python programming language. And then you can either find some other more advanced tutorials to follow, or have a look at other Software Carpentry lessons, which, let me just share my screen for a second. And show you. So Software Carpentry, I was actually about to do a recap of what the carpentries are, what the Software Carpentry is. So if you have a look at their lessons, I'll paste this in the chat as well. So you can have a look at some other things that they offer in the same style. So for example, there are actually 2 lessons in Python, programming Python, plotting and programming in Python here. They're very, very similar, but you can go and visit these materials. There are additional lessons, programming with MATLAB, but I'm sure you all already know that. Automation and make using databases and SQL. So they are all basic and introductory lessons. The carpentries don't do advanced or intermediate lessons. They just try to give people an introduction to all these tools, and they try to instill some best practices rather than teach you to program, which is impossible to do in 2 days. So you can have a look at other lessons and then just redo the material that we've covered now, and then move on to either a more advanced workshop or just try doing things yourself and asking for help on the internet. There is a big community for both Python and R out there. There is also Stack Overflow, where you can ask all loads of questions, and there is loads of people that can help, as well as Python and R communities themselves. So let me just go back to my slide. Actually, I just want to retract a bit on Git and GitHub. So Git is hard. I taught myself Git, but I think it took me 3 attempts to wrap my head around the concept of local repository, local working copy, staging area, and then the remote repository, and so on. So it is hard, so don't be alarmed if some of the things maybe that you've heard today don't make sense just yet. It will sink in. So I think what helped me and what Sam was showing you is some diagrams, because Git is not linear. You work with branches, and then you merge branches with other branches. So the best thing to do is just to have a look at the diagram to visualize things. That helped me learn Git. And also there is a tool that I use when I develop things locally, and I should have actually shared my, it's called Git K. I'll put it in the chat. Git K is the tool. So let me just show you for a second my whole screen. Am I sharing now? Can everyone see that? Can you see my shell or not?
The text quite small, but yes.
Okay, so I'll make the text bigger. Ooh, oops, no. So this is one of the Git repositories that I have locally on my machine. And I'm currently on the branch called GitHub Pages, GH Pages. So the tool that I use, I don't know if it's available for Windows, possibly not in Git Bash. So Git K, it's called the tool. And it helps me visualize all the branches that are currently present in my repository and what's going on. So when I say -- all, that just tells Git K, visualize all my branches. So this is what I get. So some kind of visualization tool might be helpful for you. You might not use GitK, but this is just to give you an example. If you work from some integrated programming environment, they might have some kind of visualization as well. So here, if I start clicking, you can see these little dots and these little branches. So and how they get merged into one another. And then you have all the commit messages. So it helps me when things get complicated. And then you can go down in history, and then you can see, for example, local branch here called software development. I don't know if you can see it, it's too small. And then you have the remote branch also called remote development, and the two are in sync, and so on. So this is just something I wanted to show you that you can help you with Git development.
I just typed that in the Windows Git install, and it has come up, though it doesn't seem to be synced to my repositories. It's sort of.
You need to start it from within your repository.
Right.
I don't know if is it Git Bash that you're using?
Yeah. Don't worry. I'm in the repository folder. It's not worked. I don't know. Don't worry.
I don't know if anyone else has tried that. Maybe it needs some extra. Has it popped up with a?
It didn't like the dash all on the end of it.
But maybe it's slightly different on Windows.
Yeah, if you just type Git K, then I've got a visual summary of what we've been doing today.
If you, I think if you just do Git K, it shows you the current branch. If you say minus all, and possibly can be something else on Windows, maybe just minus all or something like minus A, it should show you all the branches. And sometimes you want to see all the branches and see what's going on. But yeah, that's just something that is an extra. Anyway, thanks everyone for sticking with us the past few days. We did have a couple of issues with Zoom and the reactions and different versions of Zoom. So apologies for that. Zoom keeps rolling out updates very often, and we had different versions. Well, everyone seems to be having a different version, and we couldn't have used reactions and those green and red ticks and buttons and reactions as we would have hoped to. Normally in carpentry workshops, we use real sticky notes. So in a face-to-face workshop, people use different colored sticky notes on their laptops to indicate whether everything is okay or whether they need some help. And we were trying to mimic that in Zoom, but it just didn't work as planned now. But hopefully for the next workshop, everyone will have the same version of Zoom installed. Hope you found the workshop useful. And just as a reminder, our main goal was not to teach you hundreds and hundreds of commands in all of these tools, but to give you a flavor of what is available and possible, and to give you some best practices in programming. So things like use comments, write modular codes by using functions, connect smaller programs in shell together using pipes to create more complex pipelines, use Git to backup and version control your work. And yes, GitHub is your friend as well. GitHub is a almost like a social platform built on top of Git. Initially, it didn't have so many features, so now it replicates quite a lot of actual features available to you from shell. I think initially you were not able to create a branch from the GitHub interface. Now you can create a branch, you can create a pull request, you can merge pull requests, so you can do quite a lot of development from within GitHub itself. I wouldn't recommend you actually doing that necessarily. Especially if you're developing code, you wouldn't really develop code within GitHub. You would develop your code on your local machine. You would test it, make sure that everything is okay, and then you would push those changes to GitHub. But sometimes you want to do a quick change, perhaps to a README file or you spot a small typo, and then you can actually do that from the GitHub interface as well. So it's quite powerful. It's not just useful for code development, as Sam said, you can share your papers you're working on or some other things that you want to collaborate with people on. So before you go, if you can head back to the Etherpad document and give us some feedback on this last session on Git. That's the first thing I want you to do before you go away. And then after you do that, I'd like you to fill something that is called the Carpentry's post-workshop survey. And this is going to go directly back to the Carpentries. So when we ask you for feedback, we use that feedback to improve the lesson materials and the way that these workshops are delivered and taught. So, so the next time they can be even better. So can anyone from the helpers please copy the link to the post-workshop survey and paste it in the chat? I think it's linked from the workshop website as well, because I'm just now in the shared screen. Actually, I can probably do that. I'm lying. I can probably do that myself. Unless someone is going to be faster than me. So on the workshop website.
I've just done it.
Oh, fantastic. Thank you. So on the workshop website, it's linked to here from the surveys. You should have all done the pre-workshop survey as well. So back to my slides. I'll just give you a couple of minutes to do the feedback on the Git session in Etherpad, and also to fill in the Carpentry's post-workshop survey, which is going to be looked at some point by the whole community of instructors, because we are not the only ones teaching this. Carpentry's workshops are taught around the world. I'm not quite sure, but it's probably hundreds of countries have now had these workshops. I think they even did it in Antarctica. They did the Carpentry workshop. Anyway, in my slide, you have some couple of useful links. So you have the link to the whole Carpentry's community, which is a community of instructors and helpers and lesson developers that brought these workshops to you and to other researchers and scientists around the world. So you have Software Carpentry. There is a link to Software Carpentry as well, which is one of the lesson programs within the larger Carpentry's community. You also have Data Carpentry. So Data Carpentry is focusing more on data analysis. Workshops are very similar to these. So we would teach R or Python. We would necessarily teach Git and Shell, because that's taught in Software Carpentry, but we would teach data organization in spreadsheets, the best practices actually, not how you use Excel, but the common mistakes and what's the best practice to organize your data in spreadsheets. And also data cleaning. So if you have lots of messy data, how to best clean and organize your data. So that's what the Data Carpentry is doing. There is also Library Carpentry. So this is for people in the library and information roles. I've not mentioned it on my slide, but you can find out from the Carpentry's website. I just thought it might not be relevant to you. There is also HPC Carpentry, which is not an official Carpentry's lesson program, but it follows the same ethos and the same approach to lesson development and delivery. And you can look it up on Google as well, HPC Carpentry, if that's something that is of interest. We like people to get involved as well. If you liked this and if you feel that you want to get involved, maybe teach your colleagues what you've learned, perhaps not immediately, but as you start using these tools a bit more, you become more familiar, and then maybe you want to teach someone else from your community. You can get in touch either with myself directly, you already have my email address, or through the Software Sustainability's website, which is an institute, a UK's national facility, an institute that Sam and I work for, and Sam is some you're affiliated kind of work partially.
I volunteer from time to time, and they pay me to do things occasionally, but I'm not staff, alas. But I do occasionally get to go to their fancy trips to hotels, so that's the important thing.
That's nice. So if you're wondering what the Software Sustainability Institute is, I think I said at the beginning of the workshop, but I can just repeat now. So we are a national facility in the UK for cultivating better research through better software, and one part of our work is actually delivering these and other workshops to researchers, and we partnered up with the Carpentries that are based in the US but are a worldwide community, because we have so many common goals, and because we believe that what the Carpentries are doing is right. So we are a big partner and supporter in the UK of the Carpentries way of teaching and workshops. So we always need new instructors and helpers. If you want to get involved, but you're thinking, oh, maybe I'm not really an instructor just yet, you can try and be a helper initially. And we would love to support you in your local community. And then the next step would probably be, oh, I need to develop some training materials. There are no training materials for acoustics community. Let's do something specifically for your community, and that's obviously the next step.
Yeah. So can I interject there?
Of course, yeah.
If you don't mind. So and Amelia, feel free to. So yeah, I mean, this is the kind of the aim really as far as the UK Acoustics Network goes. The reason that the Software Sustainability Institute have agreed to co-fund this workshop is to try and kind of pump prime, if you like, some internal sustainable sort of best practice sharing. That's the whole point here, really. So I very strongly encourage you to consider becoming instructors to help if we're running this sort of workshop. Again, I must admit, from my own perspective, I was very, very delighted that all of you stayed around. We're obviously quite a significant number down from the original registration, which is quite disappointing, to be honest, given that there was as many people not able to get into this workshop as actually eventually signed up. So so that's a bit disappointing, but it shows the level of demand that there is out there. So we could easily fill another one of these again, but we'll have to probably do it off our own back, the way that this, the way, because they're not going to fund another one. So please do take that seriously. And then, yes, in terms of actually developing what gets called domain specific teaching materials, so things specifically to do with using, I don't know, Python, probably most obviously, for different types of computational or mathematical acoustics, then I would strongly encourage that that's something we should be doing. I mean, we've kind of more or less said that, myself, Nick and Amelia have more or less agreed that that's something we want to do. It's just a question of how. And this Carpentry's, I've just forgotten the name that Matt suggested yesterday, the sort of pilot. Incubator, thank you, yes. The incubator sounds like one possible route for that. So we will look into that, but, we don't have the time to do that ourselves. It has to be a kind of community effort, really. Myself, Nick and Amelia don't have bought out hours to do this. We're just trying to coordinate. So, for that to work, it requires people to get involved and, there to be a bit of goodwill to kind of get these things going. So, so thanks for sticking around for the full week, and please do continue to prod us and offer to help and suggest ways to help, and watch out for our summer school as well, which we're currently just finalising 5th to the 9th of July as well. It's definitely happening. So.
Yes, so our Carpentry Incubator is a way to share community developed lessons. Once they get into the state where they are really of high quality and peer reviewed, they would move on to the Carpentry's lab, and they might even be endorsed as official lessons. So what I'm showing currently on the screen is the Carpentry's incubator. And then if you look at what repositories are available there, there's just loads of lessons for various domains. I was also showing earlier, this is for the data carpentry. They have curricula for different domains. So for ecology, genomics, social sciences, geospatial data curriculum, and then a couple of others under development. So this is something perhaps that you can do. Software carpentry itself is not domain specific. It's very generic. It gives general coding skills, but you can obviously branch out and do something for your domain. And I think thanks very much to Jonathan for saying these couple of last words. I just want to thank everyone, instructors and helpers, for delivering the workshop, and to you all for being such an engaged bunch. It really helps us as well when we get loads of questions from you, and when we see that things that we are saying are kind of sinking in and hopefully will be useful to you. So yeah, a big thank you from me, and do get in touch.